Running a well-secured web application means understanding common web app security flaws and also how the bad guys think when they essentially want to break into a web app. The first thing to consider is the underlying architecture that supports the web application. That would include the hardware, the network configuration, perhaps PKI if you're using SSL or TLS, hopefully TLS, and also authentication configuration settings. In the case of Azure, bear in mind that the hardware is the responsibility of the Microsoft Azure Data Center IT team. The other thing to consider at the development level are poor coding practices, such as developers not putting in the proper input validation for web apps that accept input, whether it's through URL parameter values or through web forms. A lack of encryption is always a problem when we talk about encryption for data in transit. In other words, we should be using TLS, Transport Layer Security, to secure network connections, and also a lack of encryption for data at rest, such as not ensuring that a backend SQL database is encrypted using TDE, Transparent Data Encryption. Other considerations include at the network and operating system levels. Let's focus first on the network. We have to think about who has access to the network in the first place. For example, if we're talking about a web app that's to be used as a line of business app only internally, then there's no reason that that should be reachable, in other words, from the internet. It shouldn't have a public IP address. We mentioned that a lack of encryption, both at the storage and network levels, is always a problem. The lack of digital signatures to verify message authenticity. We should always make sure that we secure our web app backends on a user network. Now, what this means is the backend could be a SQL database that's stored on a totally separate network from the web app front end. And normally that's the case. There's usually a firewall between the two that limits access to the backend data store that the web app relies upon. The other thing to consider at the operating system level is hardening it by applying missing patches, changing default settings, removing unnecessary services and unnecessary user accounts. Now, of course, depending on how you deploy a web app in Azure will determine if you even have control at the operating system level. So if you're using an app service web app, well, you don't have access directly to those underlying VMs. So that would be the responsibility then of Microsoft. Securing connectivity to a web app means using HTTPS. HTTPS, in turn, implies the use of a PKI certificate. So the connectivity works like this. The client connects to the app. Now, the client could be a web browser or some other custom client, such as a mobile device app, that makes a connection over HTTPS to a web app component running in the Azure cloud. So what happens then is there's a bit of a negotiation to secure that connection between the client and the web app. So the client would connect over HTTPS, and then the server would send its public key to the client. There's no security risk in sending public keys publicly to everybody. The next thing that happens is the client app, normally a web browser, will generate a unique session key, and it will encrypt it with the server's public key that it now possesses. The server then uses the private key to decrypt and reveal the session key. And the session key is used from then on to encrypt and decrypt everything in that connected session. Now, bear in mind, there's really more that goes on behind the scenes, such as negotiating the specific protocol that will be used, whether it be SSL and which version of SSL, or TLS and which version of TLS. SSL is deprecated due to known vulnerabilities, so you should never use SSL where possible. You configure whether SSL or TLS is used and which versions, both on the client side, such as in the web browser, and on the web server side. At the web server stack level, we have to think about software updates, PKI certificates that might expire, which can prevent access to the web app, hence a lack of availability, which is a security issue. Having web server modules running that aren't necessary, such as to parse PHP when you're not even using PHP. Changing default settings is always a great way to harden anything, including a web server stack, whether it's a Microsoft IIS web server or maybe an Apache HTTP server running on Linux. We should always make sure we use HTTPS to secure and encrypt the connection instead of HTTP. If you're using third-party components when developing web apps, always make sure that they have the latest updates applied, that they don't have default settings in place that are known by all. and that they have the proper strong authentication configured with other components they might need to communicate with, such as a backend database. In this demonstration, I'll use the Azure portal to deploy a web application. To get started here in the portal, I'll click Create a Resource up in the upper left. Now, when you deploy a web application in the Azure cloud, it's hosted. That means you don't have to worry about the underlying virtual machine. So I'm just going to type in web, and then I'll choose web app from the results, and I'll go ahead and choose Create. So I'm going to fill in some of the details here, such as deploying this into a resource group and giving it a name. I'm going to call this web app 1725. I'm going to call it web app 17256. And it's going to add the .azurewebsites.net DNS suffix by default. Of course, you can add a custom domain name after the fact. That's what you get right out of the gate. Now, we can either specify that this is going to be deployed as a Docker container or just as regular code for a web app, in which case we get to choose the runtime stack. I'll choose .NET Core 3.0 Current, and I'll leave it on the Windows operating system. Then I'll deploy this in a region that's near where I'll be working from, which in this case is going to be Canada East. Then I'm going to go ahead and scroll down and just take a look at the app service plan. The app service plan can be associated with one or more web applications, and it is what actually controls the sizing, the underlying horsepower that supports the web application. Here we can choose to create a new one, that's the default selection, or, if applicable, choose an existing app service plan. Let's let it create a new one. Notice down below, it's set to 100 total ACUs, that's Azure Compute Units, which is a measurement of the underlying compute power, and that can be changed in the app service plan. I'm going to leave it as it is, and I'm going to choose Review and Create. It'll validate my choices, at which point we can then actually deploy the web app by clicking the Create button. And after a moment, we can see our deployment is complete. So I'll click the Go to Resource button to open up the navigation bar for a newly deployed web application. One of the things I see in the navigation bar is security. I'm going to go ahead and click on Security. And because it's a newly deployed web app and there's no activity, there's not much here in the way of recommendations. But this is going to be very important in terms of coming here to the web app to view security recommendations based on our configuration, which will also show up in the Azure Security Center, which is also accessible in the left-hand navigator when you're displaying the navigation bar in the Azure portal. If we flip over to the overview blade, notice that the URL automatically includes HTTPS, so we have a secured connection by default. The only potential downside is we're using the .azurewebsites.net default DNS domain suffix, which may not represent your organization's public presence on the internet, in which case you could scroll down and add custom domains and then add your own TLS binding to your custom domain as required. In this demonstration, we're going to use the portal to configure a custom DNS domain name for an Azure-hosted web app. So the first thing we'll do here in the portal is navigate to the web app, and I'll do that by clicking the App Services link over on the left, and then in the resultant list, I'll click on the appropriate web app. So once I open up the navigation bar for that web app, let's stop for a moment on the overview blade and take a look at the default settings, where on the right, we can see it's using the .azurewebsites.net DNS domain suffix by default. However, that of course is not representative of your organization's public DNS name, if in fact you have one and this is a public-facing web app. So we can change it. So I'm going to go ahead and scroll down in the navigation bar for the web app, down under Settings, until I see Custom Domains. When I click on Custom Domains, I'll see the default domain name that's assigned to this web app, but I can also click the Add Custom Domain link, which I will do here. And I'm going to call it lachanceit3.com. This is a DNS domain name I have already registered externally through a totally different provider outside of Azure, and I own that domain. And let's say I want to use that here as the DNS suffix for my web app. So after I put in my custom domain name, I then click the Validate button. At which point, I am then going to be asked, if required, to prove domain ownership. Now it says, to prove that you own that domain externally, create TXT and A records with your DNS provider using these values down below. Okay, no problem. Let's do that. My external DNS provider is GoDaddy, where I've registered my custom DNS domain name, and I am managing that DNS zone where down below I can see the records, and I have the option to add. So what I want to do is add both a TXT record with these appropriate values as well as an A record. So I'm going to go ahead and do that right now. Now back here in the GoDaddy web management screen, I've got the TXT and the A record both added here with the settings that were specified. So this means that if we go back to the Azure portal, then we have the option of clicking Validate. And you might have to wait a while until that gets propagated. But if we scroll down, we can now see domain ownership has passed. We are good to go. So we can now click the Add Custom Domain button, and we truly will have added it listed here, lachanceit3.com. However, currently there's not an SSL or TLS security binding, but nonetheless, we now have a custom domain name. This means if I go to the Overview blade, we can now see the URL includes our custom domain name, although it's over HTTP and not HTTPS. I'm going to go ahead and click on the link to make sure it actually does work. And indeed, it does take us there. It does work. And we can see it popped up the default web page. In this demonstration, I'm going to configure an SSL or TLS binding for an Azure hosted web application. Ideally, you'll configure your web server and your client connecting browsers to only use TLS and not SSL at all, only because SSL is deprecated due to its security issues. To get started here in the Azure portal, I'm going to go to the All Resources view and filter the list for items that have KV in their name, because I know I've already deployed a key vault named KV172. What we're going to do here is go to certificates, because we can either generate or import certificates here in the key vault to be used to secure web applications. I'm going to generate one where the certificate name will be public web app. It's going to be a self-signed certificate. The subject name will be CN equals lachanceit3.com, CN being common name. I'll click on the DNS name, that's the subject alternative name, and I'll use the same thing. In other words, lachanceit3.com. Now that has to match any custom domain names you might have configured already with your web application. We'll take a look at that in a moment. I'll click OK, and I'll just create it. I'll accept the default for that. So it's currently in progress, and we can see that up here if we take a look at our notification area. But after a moment or two, we'll be able to refresh, and after it's been created, it'll show up under completed. Now, while that's happening, let's switch over to our web app, which I already have open here in another web browser window. Now, I've gone into the TLS SSL settings blade for our custom web application, where over on the right, I've clicked on Private Key Certificates. That's at the top. Now, what we can do is import a Key Vault certificate. So I'm going to click Import Key Vault Certificate. Naturally, as you might guess, you'll have to select the Key Vault, in this case, KV174. Then from the drop-down list, there's our public web app certificate. We can see the unique thumbprint for it. So I'm going to click it, and I'll click Select. And after a moment, we can see it's healthy, and it's listed down below. So now when we go to custom domains, we can see that we've got a custom DNS domain already added here with the same name, lachanceit3.com. Let's just link the two together to secure it, because currently, if I take a look at the overview blade for this web application, what we're going to see is the current DNS name uses indeed our custom DNS domain name, but it's only over HTTP. We need that to be over HTTPS. Now, to use HTTPS to secure a web app, you need a PKI certificate. That's what we generated in the Key Vault and just added here under our TLS and SSL settings. So now I'm going to go to Custom Domains here within my web app. There's the lachanceit3.com custom domain, but it doesn't currently have an SSL binding. And so I'm going to click the Add Binding link to do just that. So there's the domain from the list. The certificate now is available here because I already added it first under TLS SSL settings. I'm going to select it. The TLS or SSL type, I'm going to choose server name indication or NSI based on server name, not IP address. And I'll simply click Add Binding. So after a moment, we can see that lachanceit3.com is now secured. So now if we go back up to the overview blade, that's where we saw the URL for our web app. We'll still see it there, but notice the difference is now it's using HTTPS because our custom domain name has an SSL binding associated with it. And if we click that to launch the web app, it's going to make a connection over HTTPS to our web app if it can resolve the name, the DNS name, to the IP. Now at this point, it says the site is not secure. Well, that's because it's self-certified. My web browser doesn't trust the issuer of the certificate. If I click on details, it says your PC doesn't trust the security certificate. I'm going to choose go on to the web page, and now we can see our default page is available over HTTPS using our custom DNS domain name. Now to suppress that kind of a warning, you either A, make sure you get your certificates through trusted external third parties. We didn't. Ours is self-certified. Or you could modify the client browser settings on all of your corporate devices so that they will trust the issuer of the certificate, which in this case is itself, lachanceit3.com. In this demonstration, I'm going to use the Azure portal to enable authentication to an Azure hosted web app because by default there is no authentication. Let's take a look here in the portal at existing app services. So I'll click on app services on the left and I'll click on the web app where I want to configure authentication. In the overview blade for a web app, what you'll notice over on the far right is the URL for the web application. And what we can gather from what we're seeing here is that indeed a custom DNS domain name has been configured and an SSL binding for it has been configured because it's prefixed with HTTPS for a secure connection. And if we click on that link, it should take us directly into the web page, the sample web page. Of course, if our web browser doesn't trust the signer of the certificate, we'll get this message about it not being secure. We expect this, so we'll just click Details, go on to the web page, and there's the sample page. But notice it did not ask for credentials, and that's what we're going to change. So I'm going to close that window, and back here in the properties of our web app, I'm going to scroll down under Authentication/Authorization. It says anonymous access is enabled. Yes, we've just seen that. So I'm going to turn on App Service Authentication and I'll click Save to save that change. Now down below it says action to take when request is not authenticated. Allow anonymous access. Well, we're going to want to make sure we tell it to log in with Azure Active Directory, and then we're going to want to configure Azure Active Directory as an authentication provider. Just to make sure we're looking at the most up-to-date information, though, I'm going to click on something else in the navigation bar. We're going to come back to Authentication/Authorization. So if I were to choose Login with Azure Active Directory, notice because I clicked elsewhere and came back, it kind of refreshed things. Now the Save button lights up. Not a big deal, just be aware of it. So I'm going to save that setting. And again, you can always check your notification area to see if it's been saving your settings, which it has been. I'll dismiss all. Again, I'm going to click on something else and come back to Authentication/Authorization. So, okay, it's got our two settings retained, but let's configure Azure Active Directory as an authentication provider. Currently, it's off. I'm going to click Express and accept the defaults and just click OK, and then save that change and monitor our notifications to make sure that it did save it successfully, which it did. Okay, let's try this out. So what I want to do is go back to the overview page only because I want to copy that URL and test it in a new browser session. So I'm going to copy it to the clipboard. So I fired up a totally different web browser and I've popped in the URL. Let's go ahead and press enter to start making a connection to it. Now we expect we'll get a security message because the certificate signer isn't trusted. This is all expected in this configuration. So no problem. I'm going to go under more information and click go on to the web page. At which point we are now prompted to sign in. We need to specify the sign-in ID or the email address for a valid user in Azure Active Directory along with the password. So I'm going to go ahead and do that. So when I enter the credentials correctly for an Azure AD user, it'll ask me if I would like to allow the permissions for the app to sign me in and read my profile. I'll click accept. Sure, no problem. And now we are in the web app. We're seeing the sample home page, and we've had to authenticate to get here. It still gives us a certificate error only because it doesn't trust the certificate signer. That's a separate issue, but the authentication portion is working just fine. When it comes to backups, most people probably think of backing up the contents of a file server, or even backing up their smartphone contents to the cloud for safekeeping of things like photos. However, we can also back up the configuration of a web application and even any backend data. To get started here in the portal, I'm going to click on the App Services link in the left-hand navigator, and I'm going to click on a web app that's running. It's called Web App 17256. It's one that I've deployed previously. In the overview blade, one of the things we'll see on the far right is the URL to the web app, which uses the default Azure Websites.net DNS domain suffix. Of course, that can be changed by adding a custom domain. But when I click that link, it shows me in a new web browser window the default sample web page, and we do have a connection over HTTPS, so it is a secured type of connection. However, if we scroll down under Settings and click on Configuration, among the many other web app configuration parameters, we'll have the option of checking out if there are any connection strings. Now, connection strings are normally used to make a connection from the front-end web app to a back-end data store. So under Application Settings over here on the right, if I scroll down, indeed, we'll see if there are any connection strings. Now let's scroll down a little bit further under Settings and let's choose Backups. The first thing you'll see is that you can enable periodic restore points, so snapshot options. However, in order to do that, you have to be using a premium app service plan, and it gives you the option to click to upgrade it. The app service plan, among other options, besides determining the feature set available for web apps, essentially lets you organize multiple web apps together, including for the purposes of sizing. You can determine the underlying compute power, for example, for the web apps hosted and made available through that app service plan. I'm not going to configure that, but down below we can see that backups are not configured, so I'm going to click the link to configure backup for the app. First thing is where the backup's going to be stored. So I'm going to click on the storage settings portion to choose a storage account. So I'm going to select an existing storage account. Of course, I could always opt to build a new one. Next thing I have to do is select a container. So I'm going to click Add Container, the new container button. I'm going to call this Web App 17256 Backups. It's going to be private in terms of the access level, and I'll click OK. And once that's there, I can select it from the list, and then the select button down below becomes available. So I've chosen a storage account and a container where I want to store the backups for this web app, but we haven't determined the schedule. So I'm going to click the On button next to Scheduled Backup. The default is to back up once a day, every 1 day, but you can also select hours and change that value up at the top. I'll leave it on every 1 day. The question is, when do we want that schedule to kick in? Right away or later in the future? So we can choose the Startup Backup Schedule from options, the date, the time, and the time zone. I'll leave the default because it's pretty much right now in my current time zone. And we can specify the retention for backups. Here it's set to 30 days. I will accept the default, and I will make sure that it's configured, as it is by default, to keep at least 1 backup. Now, because we don't have any connection strings linking to backend data sources, we don't have anything down below to put a check mark in to select to back up for backend databases. But you can back up the backend databases along with the web application. I'm going to go ahead and click Save to save our web app backup settings. And after a moment, the settings are now in effect. And we can see that over on the right. We can see our configuration based on our selections. Notice that we can also choose to back up at any time. If I click the Backup button, and then if I go to my notification bell icon in the upper right, it says that it successfully submitted the backup request. Of course, we take backups so that in the event of a negative incident, we can restore from the backups. So we can see down here, we've got one succeeded backup, one that's in the midst of being created. We can also click the Restore button to restore from web app backups when needed. Just take note that when you do choose to restore from a backup, you can overwrite the same web app or build a new app. So we've got a couple of options available both on the backup and restore side of working with Azure hosted web applications. In the Azure environment, a web application firewall, or WAF, W-A-F, is designed to protect web apps from common vulnerabilities, and it's configured within an application gateway. I've already deployed an application gateway here in the Azure portal. So I'm just going to go ahead and open up that gateway object. Now, the application gateway can be treated as a layer 7 load balancer. So it can look at the path, for example, specified in a request to determine how to route the request to backend servers. So it's got a backend pool of servers as well as a front-end IP listener. But what we're here to talk about is the web application firewall component. Now, if I go to web application firewall here in the navigation bar for that application gateway, the only problem we're going to see is it says, well, you need to upgrade to the WAF tier in order to use this. So I'm going to go ahead and switch from standard to web application firewall. And I'm going to go ahead and make sure, of course, that it's enabled. Now, you can enable the web application firewall in only detection mode, where it will detect and log or notify of suspicious activity, or prevention mode. Prevention mode means it will evaluate everything in the request except for items listed below, and you can even have it, for example, stop attacks while they are happening. Now, these would be based on web application vulnerabilities. So the web application firewall settings then would apply to the web app running in the virtual machines defined in the backend pools of this application gateway. API stands for Application Programming Interface. Normally what that is a collection of related functions. For example, you might even build a custom API with some default functions that are related to an IoT device. Or you might call upon existing APIs, such as the vast array of APIs that are exposed by Microsoft for Azure programmatic connectivity and control. So the Azure API Gateway serves kind of as a proxy. It sits between API calls from other components and the API itself. So for the API, it provides packaging, so it can be deployed and used in other locations. The publishing of it so it's discoverable and made available, and also documentation for the API. Other developers cannot call an API unless they know how the API should be called, data types or parameters that should be sent to it when called, and also return values. That can only be learned through documentation of the API. With the Azure API Gateway, one of the benefits is API throttling. This means taking a look at the amount of incoming API requests from different locations and from the same location within a small period of time, and being able to throttle it back or limit it. Now, the other thing we can think about is API health monitoring that's part of the API Gateway to make sure that APIs are functional when they're being called, so that there's a successful call, and that the API Gateway itself is functional. API connectivity, in other words, making sure that APIs are reachable, is another aspect of using the Azure API Gateway, as well as API usage analytics, so we can determine which APIs are used more than others. You can also configure an Azure API Gateway policy. Now, the policy is a way to control how APIs behave. The policies are XML files, really, that's all they are, and the policies are designed to affect API responses to API calls or requests. And there are a lot of built-in policies, or you can build your own custom using the XML file format. For example, there's a send request policy, which is used to control where requests are sent to a specific URL. You can also use the built-in check HTTP header policy to view HTTP URL strings, including parameters and values. There's also a built-in policy that you can use to check about authenticating with client certificates. That's PKI client certificates before allowing access to an API. In Azure, you can use an application security group to control the network traffic into or out of virtual machines that support a given app. So really what we're doing is grouping virtual machine network interfaces together within an application security group and then applying a network security group rule. So to get started here in the portal, I'm going to click Create a Resource and I'm going to search for Application. And I'm going to choose Application Security Group and then I'll choose Create. So I'll specify the resource group into which I will deploy this new application security group. I'm going to call it App Security Group 1 and I'll specify the region to deploy it into. I'll then click Review and Create. Validation has passed, so I'll now click Create to actually build the application security group. After a moment, we'll see the deployment of the application security group is complete. So I'm going to click Go to Resource so we can go take a peek at it. Now, when you look at the properties in the application security group, you're not going to really see anywhere that you associate it with virtual machines running certain app workloads. So what happens then is when we go to the virtual machine level, so I'm going to go to the virtual machines view here in the portal, I'm going to click on an existing virtual machine that houses a specific app. And the next thing I'm going to do is go to the networking config for the virtual machine. Now, when you look at the networking blade, besides the standard inbound and outbound port rules, which is part of a network security group, you're also going to see application security groups. There are none listed, but we do have the option to configure application security groups. What you're doing is tying an application security group to the network interface used by this virtual machine. And there's our application security group, App Security Group 1. I'm going to go ahead and save that. But you still might be wondering, well, what does that do? Nothing yet, really, until we start referring to the application security group name within inbound or outbound rules. So let's say we go into inbound port rules here for our network security group. So we can see the network security group here is called Windows Servers. Why don't we actually click on that? Now that just takes me directly into that network security group. I want to go into the inbound rules. And now if this is a web application server, I'm going to want to allow traffic from other potential locations, like from clients or from other components, such as other software components that need to talk to my web application. So when I work on a rule, for example, I will edit an existing rule. One of the ways that application security groups show up is as a source and a destination. So instead of specifying a source IP address or address range, instead I can refer to the name of an application security group. Now when you do that, as long as you've carefully associated a meaningful application security group name with virtual machine network interfaces, it's a way to refer to only a small subset of VMs running a specific workload, either from a source perspective or when you're configuring the rule from a destination perspective. So it really saves us from having to refer to specific IP addresses that refer to application workloads. So, in this course, we've examined Azure Web Application Security, including techniques for securing web apps in the Azure cloud. We did this by exploring the most common web app vulnerabilities, how to deploy an Azure web application and how to configure it with a custom domain name. We also talked about how to configure a web application TLS binding. We talked about web app authentication options, web app firewalls, and web app backups. We also discussed the Azure API Gateway and finally, application security groups. In our next course, we'll move on to explore Azure Virtual Machine Security and what can be done to reduce the attack surface of those VMs. Hardening virtual machines in the Azure cloud computing environment shares a lot of similarities with how you would harden virtual machines running on an on-premises environment, although there are some distinct differences. First of all, when we talk about VM security in Azure, this is not applicable to managed VMs. What that means is it's not the responsibility of you, the cloud customer. When we talk about a managed service, we're talking, for example, about deploying something like Azure SQL Database.
where you don't have control of the underlying virtual machines. That's handled by Microsoft because it's a managed service. And as a result, you don't have direct access to harden that underlying virtual machine. Hardening a virtual machine means hardening the virtual machine operating system and all of the settings that go along with that, along with hardening any applications running within the VM. That would also include the removal of apps that aren't being used. Azure VM Security comes in many different facets, but one thing to bear in mind is you can always refer to the Azure Security Center in the portal to get recommendations about what should be done to harden Azure virtual machines. Access control lists, or ACLs, are used to control access to a resource, such as a virtual machine. One way that that's done is through network security groups with in- and outbound firewall rules, and that can be associated with either a virtual machine network interface or a subnet on which a virtual machine resides. The other thing to consider is VNet connectivity. Let's say that you've got a virtual machine in Azure with two network interfaces, one of which might be connected to a private network that isn't visible from the internet, but the other one might have a public IP address that is visible directly from the internet. That could present a security risk in that if it's compromised from the internet, access to the private network is then possible. The other consideration is backing up virtual machines. To do that, you're going to need a recovery services vault. Replication to an alternate region, so another geographic region, is also a good idea for high availability in case we experience a regional disaster. Virtual machine disks can be encrypted. This includes the OS disk and any additional data disks, and this can be done using PowerShell for protection of data at rest. We can also use role-based access control, or RBAC, to limit administrative access to virtual machines. Now that can also, in turn, be used with MFA for user accounts in Azure AD. So before a user can sign in and gain the benefit of the permissions through the RBAC role assignment, we might require multi-factor authentication. Finally, it's important to harden the OS and the apps. We talked about settings, we talked about removing unnecessary apps. It's also important to remove unnecessary operating system components or user accounts that are no longer in use, of course, applying patches to the OS and to apps. Over time, in a larger enterprise, you'll probably end up having a lot of virtual machines that need to be managed. And one way to control management access to VMs is through RBAC, Role-Based Access Control. Here in the Azure portal, I'm going to start in the top center by searching for sub and then choosing subscriptions. I'm doing this because if I click on any of my subscriptions to open them up, I can go into Access Control IAM in the navigation bar, and I can assign RBAC roles at this level, at the subscription level. When I do that, the permissions gained from the role flow down to all of the resource groups in the subscriptions and ultimately to the resources, such as virtual machines, in those resource groups. So over on the right, I'm going to click Add, and I'm going to choose Add Role Assignment. There are a couple of built-in virtual machine roles. Of course, you can also build custom roles and use them here. So if I search for VIR, I can see, for example, I can allow administrative login capabilities to a VM and user login capabilities using those respective roles. But also I have a virtual machine contributor role, which is what I want. This allows management of VMs, but not access to them. So I'm going to go ahead and turn that on, that role. And down below, I'm going to assign it to an Azure AD group that already exists called Azure Admins. You could do it for individual users, but normally it's a better management practice to assign these roles at the group level. And whoever's a member of the group will get the permissions from that role. So Azure Admins is added down below. I'm going to go ahead and click Save. Now once I've done that, if I go to Role Assignments, I have the ability to view any role assignments at this level, the subscription. Now instead of scrolling all the way down through, which I could do, I can filter the list by role. So I'm going to click on the role drop-down, uncheck Select All, and I'm going to choose Virtual Machine Contributor. And sure enough, there's Azure Admins, the group that has been given the Virtual Machine Contributor role to this resource being the subscription. Now, having done that, in the left-hand navigator here in the portal, why don't we take a look at a resource group? I want to check to see if those permissions from that role will flow down through the hierarchy. Were they inherited, in other words? So why don't we open up a resource group, and in the navigation bar for it, much like we did at the subscription level, why don't we click on Access Control IAM. IAM, by the way, of course, stands for Identity and Access Management. So the screen looks the same when you go to the Access Control IAM settings at the resource group level. Let's click on Role Assignments, and once again, we're going to filter the roles, so it gives us less to have to sift through, for Virtual Machine Contributor. And notice that the Azure Admins group shows up here with the Virtual Machine Contributor role, and it was set at the subscription level, so here it says Inherited. It was inherited. So that means that Virtual Machine Contributor permissions are applicable for members of the Azure Admins group here within this resource group. In the same way, if we actually go into a specific virtual machine, we can do the exact same thing. Let me open up an existing virtual machine, clicking on it, open up its navigation bar, and let's click on Access Control IAM again. And what we want to do is what we've already done. We want to view role assignments, and we'll filter it for the role in question here. That role, of course, is the Virtual Machine Contributor. So I'm going to click Role Assignments over on the right, and we'll filter the list of roles. Do the same exact thing we did before, Virtual Machine Contributor, and indeed we see Azure Admins is listed here, and it was inherited from the subscription level. SSH public key authentication is considered more secure than standard username and password authentication. And the reason for this is with username and password authentication, it's just something you must know. It's one category. You need to know the username and the password, then you're in. However, with SSH public key authentication, a mathematically related public and private key pair must be generated, where the public key is stored server-side and the private key is available to the client making the connection. So that's already been configured here for my Linux virtual machine running in Azure named Ubuntu Serve 1. And in the overview blade for that here in the portal, I can see it's got a public IP address. So that public IP address can be used to make a connection, for example, from on-premises. I'm going to use the free PuTTY tool where I can place the public IP address of the host. It's going to do a port 22 SSH connection, but importantly, over on the left in PuTTY, if I go under connection SSH auth, I've specified a private key file. So the server is already configured with a public key. The related private key is the one here that I've specified. So I'm going to click open to open a connection. Now, because it's the first time I've connected, it asks if I trust the unique fingerprint of the server. I will choose yes. I'm going to log in as a user account that's created there for that Linux VM, so C Blackwell. Then it asks me to authenticate with my public key, so that's server side, and it wants the passphrase for the key. Now this is the passphrase for the private key that I have available client side. So I've set a passphrase for that file, the private key file, so I'm going to go ahead and specify that. And before you know it, we are authenticated, we are logged in. So if I clear the screen, we can see indeed we are logged in as user C Blackwell on the host Ubuntu-Serve 1. Now, that was not the user account password that I specified. It was a password that was specified when I saved the private key file, when the public and private key pair were generated. PuTTYgen is a free tool that can be downloaded and used to generate public and private key pairs, such as those that can be used with SSH public key authentication in Linux virtual machines. I've downloaded and installed PuTTYgen, and when I launch it, it looks like this. So we don't have any keys, but down below, I want to generate a public and a private key pair. At the very bottom, I'm going to leave it on RSA 2048 bits. So I'm going to click Generate. What it does then say is to generate some randomness by moving the mouse over the blank area. Now this is going to be used to generate some randomness so that we end up with a unique key pair that isn't predictable. Now at this point, it's generated the public key information. Now notice we've got a public key here for pasting into an OpenSSH authorized keys file. Well, when you're working with cloud computing in the form of Azure, it's done a little bit differently. So what we can do is highlight and copy that entire key, and we can use it to configure public key authentication within the Azure environment. But the other thing that we should bear in mind is that we could also save it as a file. We could choose Save Public Key, and we could also save the private key. We definitely need to save the private key. The private key needs to be available to establish a connection to a Linux host protected with SSH public key authentication. So I'm going to save this private key on my local machine. Now, when you're going to save a private key file, because it's sensitive, you should really have a passphrase. So I can put in the key passphrase and confirm it up above, and then save the private key. So I'm going to save it into the downloads folder on my on-premises computer, and I'm going to call it SSH_private key, and I will save that. At the same time, I'm also going to save the public key. In this demonstration, I'm going to configure SSH public key authentication for a Linux VM running in Azure. I've already used the free PuTTY key generator tool to generate a public and a private key pair. Now it's set to RSA 2048 bits that will be used for SSH public key authentication. You can see here, I've saved both the public key and the private key. The private key should always be saved with the password because, as the name implies, it needs to be kept private to the owner, whereas the public key can be shared with everybody with no security risk. I'm going to double-click to open up the public key file, let's say in Notepad. This is what the public key looks like. What I need to do here is I need to copy it. So I'm going to select it all and right-click and choose Copy. The reason I need to do this is because I need to configure my Azure Linux virtual machine with that public key. The private key doesn't get stored in Azure. That just needs to be made available on the client when an SSH public key connection needs to be made. Okay, let's go into the Azure portal. Here in the portal, I'm going to navigate on the left to the virtual machines view because I've got an existing Linux virtual machine that I want to enable for SSH public key authentication. Now, you can also do this when you are initially deploying the VM. It doesn't have to be done after the fact. Either one is fine. So I'm going to go ahead and click on an existing Linux virtual machine I've got. It's named Ubuntu-Serv1. And in the navigation bar, what I need to do is scroll all the way down towards the bottom and select Reset Password. Now, from here, I have, among other options, the ability to reset the SSH public key. I'm going to click on that. So I get to specify the username. Here I'll put in C Blackwell, and I'm going to paste in the SSH public key that I copied earlier from Notepad. That's it. Then I'm going to click Update. Just remember, though, that you need to make sure that you have the private key available client side to make an authenticated connection to this Linux virtual machine. And after a moment, it'll be done. You can open up your navigation icon in the upper right to see, in fact, that it successfully reset the SSH key. Let's take a look at what we need to configure client side with the private key. I've downloaded and installed the free PuTTY tool, which I can use to make a remote SSH connection over port 22. I've already pasted in the public IP address of my Ubuntu Linux host running in Azure. Now, the private key. What we need to do here in PuTTY in the left-hand navigator under Connection is open up SSH and then click on Auth, where we can specify a private key file for authentication. So I'm going to go ahead and select my SSH private key file that is mathematically related to the public key that was configured with the Azure Linux VM. Now, once you've done that, you might want to, for example, go back to session and save all of those settings. When I say all those settings, I mean the IP address that you've placed here and the private key that you specified. So now that you've got the public and private key in place correctly, they can be used for authenticating to SSH. Azure HDinsight is an Azure managed service that essentially provides large-scale data analysis services. So it's really designed for big data analysis. It's a managed service, and that's important because Azure HDinsight uses a cluster of virtual machines working together to perform the analysis on vast data sets. And so because it's managed, we don't have to worry about the manual configuration of the cluster and the virtual machines that comprise the cluster. So we've got no clusters that make this all happen in the background. Now, when you want to work with HDinsight, you have to work with large data sets. And that often involves extract, transform, and load, otherwise called ETL. This means copying data from the source. Whether it's a combination of SQL and NoSQL databases and log files and standard Office productivity files, whatever the source is, the first part is getting that data from the source copied so it can be used with HDinsight. Now, the transform part means essentially converting the source data to a different format that is easily consumed by the target. As an example, we might have data sources that store dates in a particular format that is not compatible with the analysis tools that we'll be using to analyze that data. And so we might want to convert or reformat those dates in an acceptable format. Finally, the last part here is to load the information into a data warehouse. Now, this would be for long-term storage, or it could be for short-term storage, depending on the nature of the type of data that needs to be analyzed. HDinsight can be used for machine learning, otherwise called ML, or it can be used related to IoT devices, Internet of Things devices. With machine learning, we're talking about gaining insights from large amounts of data that are analyzed through the HDinsight cluster nodes. The end result is that we can draw conclusions from that, such as predictive analysis. Now, machine learning really strives to mimic human behavior and make intelligent decisions when it's analyzing the data. Internet of Things devices are many. It would include things like smart cars, cars that report statistics over the internet to another location, or baby monitors that do that, or home video surveillance systems, home environmental control systems. All of these types of devices can control these aspects of our lives and send information over the internet. And so HDinsight can gather that type of information, in other words, IoT device telemetry, and we can draw conclusions from those large data sets over time. Now, securing HDinsight means installing the HDinsight Enterprise Security Package, otherwise called ESP. Now, what does this give you? One of the benefits is it allows you to integrate with Azure AD authentication. It also allows you to use role-based access control, or RBAC, for delegated administration for the HDinsight cluster. The other thing you can do is limit access to the cluster VNet, so the virtual network in Azure where the cluster nodes are deployed. You can protect it by limiting access using network security groups, so controlling inbound access with inbound network rules. You can also enable auditing of the cluster through the Azure Monitor service. Finally, you can also enable encryption of data at rest in the HDinsight cluster. In Microsoft Azure, virtual machines can use extensions. Extensions are essentially small software agents that we manage at the Azure level, but they actually manifest themselves as actual software running within the VM operating system. So to get started here in the portal, I'm going to click on the Virtual Machines view over on the left. Now what I want to do is open up an existing virtual machines properties. So I'm going to choose a Windows Server 2016 VM that is up and running. And then in the navigation bar, I'm going to click on Extensions. Now this is going to do two things. It's going to let me view any existing extensions where the provisioning status is important, if it failed or it succeeded, and it will also let me add new extensions. So I'm going to go ahead and click Add. Now it's important that the VM be running when you do this. Now when I add an extension, I have an alphabetical list of different types of extensions available from a variety of vendors, not just Microsoft. And so one of them is from Microsoft Corporation. It's the Microsoft Anti-Malware extension. Now when you add an extension to a virtual machine, you'll get a little bit of detail about it, so that's fine. I'm going to click Create. And depending on the specific extension, you might also have some configuration parameters, as we do here, such as specifying excluded files and locations, or file extensions, or processes that we don't want to include when we scan for malware, because it might trigger false positives. We can see here that real-time protection is enabled. I'm also going to turn on scheduled scans. I want that to be enabled. And we can specify whether it's a quick or a full scan. I'm going to choose full. And I'm going to specify Saturdays, assuming that's not a busy workday normally. And the scan time is 120 minutes. So these are things that you would normally configure manually directly within an operating system when you configure this type of software. But the nice thing here is we have this control at the Azure level outside of the VM OS. So I'm going to go ahead and click OK to install that anti-malware VM extension. And after it's been deployed, it will show up in the list. If you go to your notification icon in the upper right, you'll see, in fact, that the deployment succeeded for that virtual machine extension. IT technicians are well aware that it's important to apply the latest updates to an operating system in order to secure or harden the environment. Now, one way we can do this in Azure is using the Update Management facility. So instead of having to drill into each and every operating system through remote access to configure updates, we can do it at the Azure level. Here in the portal, I've opened up the properties of an existing Linux virtual machine. And in the navigation bar, I've scrolled all the way down under the Operations section and selected Update Management. Now, in the Update Management blade over on the right, it says that in order to use this, you need a log analytics workspace that's linked to an automation account. Okay, and if we've done that, we can then enable it for this virtual machine or for VMs in this subscription. Why don't we back out and take a look to see, in fact, that we have an automation account and a log analytics workspace. So I'm going to go to the All Resources view to check these dependencies, because if they're not there, you have to create them and associate them. So I'm going to click Type, and we're going to change the filter. I don't want to select all. Let's start with looking at log analytic workspaces. So log analytic workspaces, and I'll click outside, and the filter will then be in effect. So I'm going to click on one of my default workspaces that's listed here, because when you're in a default log analytics workspace, or any log analytics workspace for that matter, you can scroll down and see which virtual machines are connected to that particular workspace. So I can see, for example, Ubuntu-Serve1 and WinServe 2016-1. Both of those virtual machines are connected to this log analytics workspace. Other virtual machines are not connected to any, and others are connected once again to other log analytics workspace. We don't care about the other ones. We only care about our default workspace here. The reason is because, let's just go back here and filter the All Resources view. We don't want to see everything. All I want to see here are automation accounts. I've created an automation account already here. It's called Canada East Automation Account. Now, within that automation account, if I open it up and look at the properties of it, one of the things that's very important under Update Management is to ensure that you've linked a log analytics workspace to this automation account, which I have already done. So because I've already done that, we can see here that we've got two virtual machines that don't have Update Management enabled. That's interesting. That would be the two virtual machines connected to the log analytics workspace. If I scroll down further here, you'll see that the linked workspace, in fact, will show up in here. So we can see the name of the linked workspace, and that's where it's getting those VMs. So let's go back into Update Management. Now, what we can do here from this perspective, because remember, we could have enabled Update Management at the individual VM level. We can click Add Azure VMs here. And from this list, we'll see any VMs that are available as a result of our linked log analytics workspace. And there they are, Ubuntu-Serve1, WinServe 2016-1. Let's click Enable. And now up here in our notification area, we can see that this is in the midst of being configured, enabling Update Management on those two VMs. And we can now see that it's already enabled for those virtual machines. So if we were to go back, let's say, to one of those virtual machines, so go to the virtual machines view and open up, let's say, our Ubuntu Linux virtual machine. What I want to do is go back and look at the Update Management option here within the individual VM. Now this screen looks quite different, and you get the same type of thing for Windows virtual machines, except of course the updates will be different because it's a different type of OS. So we can see updates that are listed here and the classification. So we've got a number of updates here that are available to be applied. And we can also filter them by name. Now we also have the option here of scheduling an update deployment. So if I click that button up at the top, we can determine which type of updates to include or exclude. We can make a schedule, and we can also determine if a reboot should be allowed. So we can choose reboot only if required. So depending on the nature of the updates, it might require a reboot, in which case it will do it if we select this option. We can elect to never reboot if it's an important VM that runs mission-critical software, and we want to control that outside of this configuration. We can choose always reboot or only reboot will not install updates. So in this way, we have a centralized way to manage updates at the Azure level, instead of having to go into each and every individual virtual machine. In the Azure portal, you can easily enable the backup of Azure virtual machines. In order to do this, you need to have a recovery services vault already configured. To get started here in the portal, I'm going to go to the Virtual Machines view over on the left. In this example, I want to enable backup for an Ubuntu Linux virtual machine running in the cloud. So I'm going to click on that virtual machine to open up its navigation bar, and I'm going to scroll down under Operations and choose Backup. The first thing I'm going to need to do is select the appropriate recovery services vault. We can either select an existing recovery services vault. I've got one here already created called Vault East, but you can also create a brand new one if you wish. Now, within a recovery services vault, you will have one or more policies that determine how backup behaves. We've got a default policy, then we've got a custom policy that was created here called VM Policy 1. And notice, for example, in VM Policy 1, when we select that backup policy, the backup frequency is daily at 11 a.m., whereas the default policy is 10:30 p.m. So we get different settings, but certainly it's more than just the backup frequency, because it also deals with retention of daily, weekly, monthly, and yearly backup points. Now, once we've selected the appropriate policy for backup for this VM, we click the Enable Backup button at the bottom. Once backup is enabled, you'll then see this screen when you click on Backup in the VM properties. Now, we don't have any abilities yet to restore because we've just enabled this, but we do have an option to click Backup Now, which I will do at the top. Now, for the backup retention, I'll accept the default and I will click OK. You can monitor the progress of a backup here in the Backup blade under Alerts and Jobs by clicking View All Jobs. So here we can see, for example, that the backup configuration for our Ubuntu server has completed, but that it's in the midst of creating the backup of the virtual machine. And depending on how many disk volumes and how many files are on those disk volumes exist will determine how long this will take. If you're going to be deploying a lot of virtual machines in the Azure cloud, one idea is to have a centralized way to manage them when it comes to inventory and tracking changes to them. One way to do that is through an automation account. Here in the Azure portal, I'm going to go to the All Resources view, and I'm going to look for automation accounts. I've already created one and associated it or linked it with a log analytics workspace. So I'm going to click on Type up above for filtering, remove the check mark for Select All, and I'm going to turn on Automation Account. And I'll click outside to filter the list. I've got one here called Canada East Automation Account. If I open up that automation account, we'll see that it's already been linked to a log analytics workspace. I can see that if I scroll way down towards the bottom under Related Resources and look at Linked Workspace. So we can see the name of the workspace here that it's linked to. And if we click on the link for that workspace to open it up, we can see which virtual machines are connected to that workspace. So I can scroll all the way down until under Workspace Data Sources, I click on Virtual Machines. What I'm looking for here is whether or not it's connected to this workspace. There are only two here, Ubuntu Serve 1 and WinServe 2016-1. Those two VMs are connected to that workspace. That workspace is linked to this automation account. And here in the automation account, we scroll kind of back up. Under configuration management, you'll see three things: inventory, change tracking, and state configuration, DSC, desired state configuration, to bring machines into compliance with a standard baseline for configuration. We're here really to talk about inventory and change tracking. So when I go into inventory, we have to enable this. And you can also view this at the individual VM level, which we'll look at after. So all I have to do at this point, because I've already got the Log Analytics workspace linked to my automation account, all I have to do here is click Enable. Now the next thing we can also take a look at here in the navigation bar is change tracking. So we can track what has changed over time with VMs. And in the same way, down at the bottom, I'm going to click Enable to turn that feature on. Now, if I return to inventory here in my automation account, it says that two machines don't have change tracking and inventory enabled. Okay, well, I could click Add Azure VMs up at the top, and we should see the virtual machines that are connected to our Log Analytics workspace. They're both there, they're both selected, so I'm going to click Enable to get this process started. So we enabled inventory, then we enabled it for the individual virtual machines. So I'm going to close out of that blade, and I'm going to take a look at change tracking now that we've enabled that. And in much the same way, it says two machines don't have this enabled. Well, I'll click Add Azure VMs at the top. Of course, we'll expect to see our two virtual machines listed here. So it says already enabled. Excellent. So now we've got change tracking and inventory enabled for the two virtual machines that are connected to our Log Analytics workspace. Now, we'll take some time to gather that information, but at the same time, if we go and look at the individual virtual machine level, so I'm going to click on the virtual machines view, and then I'm going to select an existing virtual machine that I know inventory has been enabled for, so my Ubuntu Serve 1 Linux virtual machine. If I scroll down in the navigation panel for that Linux virtual machine, under Operations, I'll eventually see both inventory and change tracking. So if I click on inventory, for example, if there's any inventory that's been gathered yet for this virtual machine, it would show up here. But remember, it can take some time.
You can enable replication of a virtual machine from one region to another geographical region to increase the availability of the virtual machine should there be a regional-based disaster of some kind, or an outage. So to get started here in the portal, I'm going to navigate to my virtual machines view. And in this case, I'm going to enable replication for a Linux-based virtual machine. So I'm going to click on it to open it up here in the portal. The next thing I want to do in the navigation bar to enable replication is scroll down under Operations and choose Disaster Recovery. On the right, we can see it automatically suggests a target region of Canada Central, although we can choose from the list. And if we look at the map down below, along with the legend, the current source region where the virtual machine exists is listed here in blue on the map. That's Canada East in this particular example. And the selected target region is listed in purple, and that's Canada Central. So it's the next region over. So it's still a different region, but it's not too far away to introduce too much network latency in synchronizing the replicas. So I'm okay with this. I'm going to choose Review and Start Replication at the bottom. Now, depending on how big the virtual machine is, how many disks it has, and so on, will determine how that goes. Now, if we scroll down below, we can see here that it's going to configure target destination information. You can actually see that if you go under Advanced Settings. So you can see the new resource group that will be created in the target region, because we've got the source, as well as the virtual network. And after we're done with that, if we're okay with those settings, we can choose Start Replication. Virtual machine scale sets are related to security because they increase application availability. So virtual machine scale sets essentially load balance client requests for an app to a back-end pool of virtual machines. Because there's more than one virtual machine serving up the app, it becomes resilient to failure. So let's get started here in the portal to create a virtual machine scale set by clicking Create a Resource in the upper left. All I'm going to do is search for scale, and I'll choose Virtual Machine Scale Set. And then after that, I'll click the Create button. I'm going to call this VM SS1789. That's the name of the virtual machine scale set. Now, each virtual machine in the backend pool needs to use the same operating system disk image. Now, you could also browse private images where you might have uploaded a private image that includes not only the operating system, but also the application that you want to load balance. In this case, I'll just leave the default selection of Windows Server 2016 Data Center. I'm going to deploy this into a resource group, so I'll select that. I'm going to deploy this into a location of Canada East. Now I need to specify the username and password information to authenticate, if needed, to the backend virtual machines. And because I'm using a public image, I certainly will need to do that to load my application software and settings in those VMs. The default instance count will be 2. I'll leave that as it is, and we can see the instance size, which might need to be changed to accommodate the intensity of the workload to support the app. I'm going to leave it as it is, and I'm going to scroll all the way down because I can also enable auto-scaling for my virtual machine scale set. So let's set the minimum number of VMs to 2, maybe the max to 5, and I'll accept the defaults such that when the CPU threshold percentage exceeds 75%, we will increase the backend pool by 1 VM at a time, and then when it is less than 25%, we'll reduce. So we can scale out by adding VMs, or we can scale in by removing VMs depending on application requirements. Now down below, I can also load balance this through an application gateway or a load balancer. Now I can choose existing application gateways or existing load balancer information, or I could choose none. So I'm going to link this to an existing application gateway named AppGW1. So after I've done that, down below, I have to determine, do I need a public IP address per instance? I'm going to leave that off because I could configure inbound NAT rules at the application gateway level to allow that kind of inbound access. There's no reason to have a public IP visible for each and every backend VM. So I'll leave that off, which is a good idea from a security standpoint. Other than that, I'm good to go. So I'm going to click Create to build this virtual machine scale set. So I'm just going to go to the All Resources view so we can take a look at our virtual machine scale set. Now in the All Resources view, I'm just going to filter by the name VMSS. And there's our VMSS1789 that we deployed. I'm going to click to open that up. Now the reason I want to do this is I want to check to see how many instances are running in the back end to support this. So I'll click Instances in the navigation bar. And we can see that our minimum number of virtual machines has been achieved here because we haven't had more than 75% of CPU utilization as per our auto-scaling config. Notice the name of the VMs is that they start with the name of the virtual machine scale set, VMSS1789. But if I go to the virtual machines view here in Azure, they will not show up. They're not standard virtual machines that we manually control and deploy. They are controlled instead through the virtual machine scale set. Server administrators have long used scripts to automate administrative tasks. We can do the same thing here in Azure with virtual machines through using run commands. For instance, I'm going to navigate here in the portal to the virtual machines view, and I'm going to open up an existing Linux virtual machine, although it could just as well be a Windows virtual machine. With Windows, you can run PowerShell scripts. With Linux, you're running shell scripts. So here on my Ubuntu server, I'm going to scroll all the way down towards the bottom because what I'm looking for is run command. When I click on run command, I'll see any pre-existing scripts that I could run, such as ifconfig to list the network configuration on this Linux host. So let's just say for fun we want to run that. I'm going to click on it to open it up. I could specify command line arguments. I can also expand script to see what the command is, and I could simply click run, and we can expect after a moment the output to appear right here on the screen. And after a moment, we can see the result of the ifconfig command. We can see the IP address for the network interface. Of course, we can also run a shell script here. When we click on Run Command Script, we get to actually type in the contents of the script that we want to run on that virtual machine. Let's go to a Windows virtual machine. So I'm going to go back to the virtual machines view over on the left, and we're going to do much the same thing, except for the Windows platform. So I'm going to open up Windows virtual machine, and then the navigation bar, we do the exact same thing we did with Linux. We scroll down until we come across Run Command. Although you'll notice here that there are quite a few more built-in scripts available here for Windows. So to disable Windows Update, to enable remote PowerShell sessions, and even to run ipconfig, why don't we run that one? So again, we can look at the script here. It's just ipconfig/all, standard Windows command. Let's go ahead and click Run. And after a moment, we can see the result of running the ipconfig command here on the Windows virtual machine without having to remote directly into it. Of course, we can also run a PowerShell script by clicking on that and then specifying the statements that we want to execute and then clicking Run. You can execute any valid statement that would normally run in PowerShell in a Windows-based Azure virtual machine. You can do that through a run command. Just like with the Linux virtual machine running in Azure, you can run anything that is normally valid in a shell script. So here in the portal, I've navigated to an existing Windows virtual machine, and so in the navigation bar, I'm going to scroll down under Operations, and I'm going to choose Run Command. On the right, I'm going to see a number of existing statements that I can execute, such as enabling remote PowerShell, ipconfig, and so on. But here I've also got an option to run a PowerShell script where I get to decide exactly what those statements are. So here, for example, in line 1, I'll use get-service to return a list of services on the local host. Now, when I say local host, I'm talking about this Windows virtual machine running in Azure. And because I know that virtual machine is running Azure AD Connect to link on-prem AD to Azure AD, I know it's also got the commandlets related to that, such as start-AD sync cycle. I'm going to do a policy type of delta. In other words, I want to force a delta synchronization. So the point is that anything that normally would be valid running in PowerShell there is also going to be valid done this way through a run command. It's just running in PowerShell on that Azure virtual machine. Let's go ahead and click Run, and then after a moment or two, we'll see the output of both of those statements down below. So here we can see the result of running get-service. We can see a list of all the services and whether they're running or stopped. And at the very bottom, we simply see result success, which is normally what we see when we force a delta synchronization of Azure AD Connect. In Azure, a network security group, or an NSG, is a cloud resource that can be associated with virtual machine network interfaces or subnets, and they have inbound and outbound rules that control traffic flow. So essentially, it's firewall ACLs. Now, what we can do is go to a virtual machine and view the effective rules, because you could have network security groups associated at the subnet level and at the virtual machine network interface level. So here in the portal, I'm going to navigate to an existing virtual machine. I'm going to click on it to open up its navigation bar, where I'll then scroll down under Settings and click Networking. This is where all things networking related to this VM will be seen, including any relationship to network security groups. So we can see inbound port rules here from a security group that happens to be called Windows Servers that's attached to a network interface. We see all that information here. We've got inbound rules. We've also got outbound port rules. However, I'm going to click the effective security rules up at the top. This will put them all together to show us what's actually in effect. And what we have to bear in mind is that rule processing stops at the first matched rule. And the rules are ordered by the priority number, which you'll see in a moment when the page loads. So, if I scroll down a little bit, priority 100 is checked before priority 65,000. And so in this case, our inbound RDP rule would be checked before our allow VNet inbound rule, which is a default rule. And if there's a match on the inbound RDP rule, whatever it says to do, whether it's allow or deny, we can scroll over to the right and see access, will take effect, and then there's no more further rule processing. And the same goes for outbound rules. So using effective rules, we can determine exactly what kind of traffic is allowed into or out of a specific virtual machine. After you've enabled VM backup in Azure, and at least one backup has been taken, you then have a couple of restore options from that backup. Let's take a look at that here in the portal, where I've already opened up an existing Linux virtual machine's navigation sheet. And if I scroll down, under Operations, we'll see Backup. Now, because Backup is already configured, we are presented with this screen where we can see down below that we've got a couple of restore points available. We can view jobs in the last 24 hours. So if I take a look, we can see that backup was configured for this Ubuntu server, and also backup was completed. So we can see the date and time, of course, even the duration of the backup. Close that screen with the X. Now notice at the top, we have the option of forcing a backup now. We don't need to do that. We've got a recent backup, but we do have a restore VM option. Now, you've got two ways to look at this. You can either restore the entire virtual machine. By that, I mean creating a new virtual machine. You're making another one from the selected restore points. I'm going to select a restore point here and choose OK. Now, when I get to step 2, restore configuration, the default is to create a new virtual machine. And so it wants a new virtual machine name. And we've got the normal collection of items that are required, like the resource group and the network and subnet affiliation and a storage account. Now, we also have the option of restoring disks. So what this will do is actually restore the disks in the current virtual machine that this backup pertains to. Now, you would do this if you wanted to make sure that you kept all of the rest of the configuration of the VM the same and you want to get back to a certain point in time related to the backup of those disks. So in this example, I'm going to choose Create Virtual Machine. I'm going to call it Ubuntu-serve1-restored, and I'm going to select a storage account for the VM disks, and then I'm going to click OK. And then I'll click Restore. Now, if I click on View All Jobs for the last 24 hours, as you might expect, we can see the restore operation is currently in progress. So I'm going to go ahead and close out of that by clicking the X. Here in the Virtual Machines view, if you refresh, before too long, you'll see that the restored virtual machine will appear. After you've enabled backup for an Azure virtual machine, you have a number of restore options. You can restore to a brand new VM, you can restore the disks to the current VM, you can also choose specific files to restore, which we're going to do in this demo. So the first thing I'll do is open up the virtual machine in question that has backup configured. Now when I do that, in the navigation bar for the VM, I want to scroll down under Operations and choose Backup. Not because we want to take a backup, that's already been done, but because we want to restore files. And you'll see here that at the top we have File Recovery as an available option. I'm going to go ahead and click on that. The way this works is we choose the appropriate recovery point that we want to essentially browse or peruse to select files to restore, and then we download a script, at which point it will generate a password that will allow us to mount it as a local drive. So I'm going to click Download Script. We can see now it's generating the password that will be used to connect to this mount point. And at this point, I'm going to go ahead and save this script.
After virtual machine inventory is enabled, after giving it a bit of time, you'll be able to start seeing the results of that work. For example, here in the portal, I'm going to open up an existing Linux virtual machine where inventory has already been enabled. I'll scroll down in the navigation bar and you'll see inventory listed here. Now this is where it can be enabled, or it can be enabled through an automation account. Either way, an automation account and a log analytic workspace are required for this. But give it enough time, you'll be able to come here and see, for example, a lot of the software and the versioning information for those pieces of software, and when it was last refreshed, listed here. So you have a sense of what is available on that Linux host. If you go to the Linux daemons link, you'll also see a list of daemons and which ones are running and which ones are stopped. At the same time, you can also edit settings where you can start tracking changes to files. So currently, it's only going to do that for /etc, any file that ends with conf, but you can click add, and you can specify your own specifications in terms of paths and item names. Now, at the same time, I'm going to go ahead and close that. We can also go and ask for change tracking for the contents within files. And as we know, when it comes to config files in Linux, they're, for the most part, text files. So down below, I could click link and specify a subscription and then a storage account to store that information. Notice that it tells us that it's going to create a change tracking blob container in the storage account as this starts happening. So this is a great way then to have an automated way to track the inventory in terms of changes to files or the number of daemons running on a Linux host. At the same time, if we click change tracking over on the left, it focuses specifically on that configuration changes. And we'll see the previous setting as well as the current setting that resulted from that change. So we can see at the top, it's the last 24 hours. We can change that. But here I might say, well, it looks like we've got a number of changes made to a number of different types of resources. And if we're curious about any one of them, we would click on it. And then we'd be able to see the previous and the current change, so the value before and the value after. Now, in this case, all we're really seeing is some built-in operational items that are being listed as changes here in change tracking. You enable VM replication to an alternate region for high availability reasons, so that if there's a failure in the primary region, for example, you've got a replica of that VM elsewhere. But you can also use it for planned failover purposes. For example, here in the portal, I've navigated to an existing Linux virtual machine, so I'm just going to scroll down in the navigation bar until I come across disaster recovery. Now, this is replication, and it's already been enabled. So after replication has been enabled and it's established the replica in the target location, then you can view some details, such as the replication health is healthy, the status is that it's protected, the recovery point objective, or RPO here, is only up to 5 minutes of potential data loss. And if we were to click on compute and network, for example, then we would see the details in the target where that virtual machine is running. The name of the virtual machine, the resource group, the sizing information, the target virtual network, and so on. So if I go back to the overview blade, then what I can do is initiate a test failover. Now, you don't want to run an actual failover. This is a planned failover, naturally. But you don't want to do that until you first run a test failover. So when you run a test failover, what you're doing is specifying that you want to fail over to a target virtual machine. And I'm going to choose the latest processed recovery point, and I'll choose the target virtual network that was created automatically when I enabled replication. It's got an ASR for Azure System Recovery, so that's fine. I'm going to click OK. And it's currently happening. So we're going to wait a moment to make sure that it establishes the target, in other words, failing over to it, to make sure that it works correctly. So that in the future, when we actually want to run a failover, or if there's an unanticipated failure in the primary region, then we'll be good to go. We'll know that it's going to work. So after a moment, we'll see that it's initiating the test failover. If you don't see that, don't worry. Just click More and refresh. Just refresh the screen. So I'm going to click on Initiating Test Failover so we can track it a little bit more in depth. So the prerequisites for testing failover are successful. It's now creating the test virtual machine based on what's been replicated in the target region that's currently in progress. And before too long, we can see that everything's been done. It's created the test virtual machine and prepped it and started it. So that means then we should see a new virtual machine running in here because it's created it. Now, the original virtual machine is Ubuntu Serve 1. It exists in the Canada East region. I've enabled replication to Canada Central, and so here it is, Ubuntu-Serve1-test. The virtual machine is running. We can see the resource group is a different resource group with the ASR suffix, and it's in the target region. So what you do at this point is you want to make sure you clean up your test failover environment. You don't need to keep that virtual machine running after you've verified that it is up and running. You might even try to connect to it, depending on the type of workload in it, to make sure it's truly and fully functional. So I'm going to scroll down here in the original source virtual machine properties to disaster recovery. And all we're going to do here, once it pops up, is we're going to clean up our test failover environment. There's no sense keeping extra virtual machines running when they're not needed. So I'll do that simply by clicking Clean Up Test Failover. I'll then choose Testing is Complete, delete Test Failover Virtual Machines, and I'll click OK. So, in this course, we've examined Azure VM Security and how to reduce the attack surface for Azure VMs. We did this by exploring what can be done to harden VMs and how to use roles to limit VM admin access. We then talked about how to enable SSH public key authentication for Linux VMs and how to generate those SSH keys using PuTTyGen and enable SSH public key authentication, even for existing Linux VMs. We took a look at how we might harden Azure HDinsights, and we took a look at how to install an anti-malware VM extension. We also took a look at how to manage VM OS updates individually at the VM level or centrally through an automation account. We talked about how to enable VM backup and inventory and change tracking data. We also talked about replicating VMs, deploying VM scale sets, and executing VM run commands. We talked about VM configuration management data, such as change tracking information. And finally, we talked about how to view Virtual Machine Network Security Group effective security rules. In our next course, we'll move on to explore Azure application containers, including how to secure their use and how to manage them. Developers love building software in application containers, not only for development purposes and testing, but also for actually running it. An application container, as you see pictured in the diagram, contains application files and settings, but it runs on top of an engine. One common engine is Docker. Docker is an engine that's designed to allow the running of multiple containers. Now notice that the host operating system is at the bottom of our diagram, and the host operating system is not contained in any way within any of the application containers. Now, one of the reasons containers have a fast startup time is because the underlying OS is already running. So really, application containers then would show up as running processes within the host operating system. Containers are based on images. Now, what's an image, you might wonder? Well, when we're talking about application containerization, an image is what a container is built from. The container is the runtime version of that image, and the image contains the software for the app and settings. Images can also be organized in registries, otherwise called repositories. So for example, your development team in your organization might start to come up with application images that they would use as a starting point for future development. And you could have a number of those that are perhaps some designed to run on Linux and some designed to run on Windows. So we know then that an application container will contain the app software files and the settings that go along with the application. There could also be application-specific libraries that are normally not present in the underlying host operating system, so libraries and components, and also any runtime app and environment tools that might be used to configure or troubleshoot that application. When you're working with containerized applications in the Microsoft Azure cloud environment, there are some security issues to think of. The first of which is to isolate workloads. Developers will often create microservices, each in their own independent container. And so a lot of the workload components are already isolated. But what we're talking about here is at the network level. So making sure that our containerized application workloads are running in containers that are running on hosts that are isolated from a public network. The other aspect is to monitor activity, as we should always be doing. That means monitoring activity not only on what's happening within the application container, but also in the host operating system that is running that application container. We shouldn't run containers with root privileges. The reason is because remember that a container is essentially a running process in the underlying host operating system. And so if the container is running with root privilege and it gets compromised, that could lead to access to the underlying host OS. Other than that, we should make sure that we reduce the container attack surface. That would mean disabling components that are related to the app that are not required and removing items such as security credentials that might be used in the container to connect to a backend database that are stored in plain text files. Bear in mind that when we have multiple application instances or containers running, they're all running on the same underlying host operating system. Now, what's interesting about this is we can have multiple app instances even at different phases of development. And so that can speed up the repair of known problems, such as security holes, with apps. Azure Container Registries are image repositories. And for added resilience, you can enable geo-replication in the event that there is a primary region failure of some kind or an outage. When it comes to using image repositories, it's very important that we trust the source. So remember that we bring down images for containers, and then we launch them, and then they become called containers. Now, while it's executing, we want to make sure there's not any malicious code running. So it's important to trust the image repositories that contain the images that you will be using. Remember that a compromised OS kernel could also be a problem. So maybe the container itself isn't being compromised, but the host operating system is. And containers, of course, run within an operating system as a process. So we want to make sure we apply standard OS hardening techniques to secure the underlying host operating system. Another issue is that because containers are so quick and easy to spin up, you could end up with a lot of them, container sprawl. That could present a security risk in the sense that we might keep containers running without realizing it that allow access to other parts of an application, which could lead to access to sensitive data. The other thing to watch out for is that, again, because they're so quick and easy to spin up, containers often will have a very short life, especially during development cycles. And so it becomes difficult to pinpoint security issues that might be logged, since the container might long be gone and no longer exist. Azure Kubernetes Service, otherwise called AKS, is a managed service that allows for the clustering of nodes that will run containerized applications or containerized workloads. These application containers can even be migrated from on-premises into the Azure cloud, or you can define new containers. Now, containers are based on images that contain application files and settings, and you can pull down those images from public repositories, or you might exclusively use only private, customized image repositories. But either way, the containers can run within the Azure Kubernetes Service cluster when you have large-scale workloads or data analysis types of workloads. On the security side for AKS clusters, the first thing to consider is that when you deploy the AKS cluster, you are deploying it into a VNet subnet. And of course, subnets can be associated with network security groups or NSGs. What will happen by default is there will be an inbound rule to allow TLS traffic, essentially HTTPS traffic, over port 443, to the Kubernetes API server. Now, you can modify or adjust those rules as needed, but even when you do things like configure load balancing and so on, it will adjust the network security group rules automatically. The other security consideration is Azure Kubernetes RBAC roles. there are a couple of roles that are built in that you can use to assign it the subscription, resource, or more detailed granular scopes to allow permissions such as to use the Kubernetes cluster or to administer the Kubernetes cluster. The Azure Kubernetes API, or Application Programming Interface, exposes functionality at the programmatic level. And one of the things that you can call on in the Kubernetes API is to generate secret keys. Now, these keys or credentials might be used by nodes within the cluster to access other resources. And so, because they are sensitive in nature, they are not written to disk. They're stored only in memory. The other thing you should consider is limiting API access in the first place by using Azure AD authentication. In this demonstration, I'm going to use the portal to manually deploy a Linux virtual machine that contains Docker. I'm going to do this from a template. To get started here in the portal, I'm going to click Create a Resource in the upper left. And I'm going to search for the word template, and then I'll choose Template Deployment. And then after that, I'll click Create. Now what I want to do is search through the GitHub online repository for a template. I'll just search, let's say, for the word Docker. Now by searching, we have the ability to select from a list of available items that are available in that repository. So I'm going to choose Docker Simple on Ubuntu in this example. And then down below, I'm going to click Select Template. Now I'm going to have to fill in a few details here. So I'll fill in things like the resource group, the admin username. I'm also going to specify things like the DNS name for the public IP. So that has to adhere to DNS standard naming rules. I'll call it Docker Pub IP. Scrolling down further, I'm also going to change the default SSH public key authentication to password, and I'm going to specify a password here. I'm only doing that because I don't have a public key ready to use public key authentication. Then down below, I'll agree to the terms and conditions, and I will click Purchase. Now that specific template did not give us the opportunity to specify a VM name, and so it's called My Docker VM by default, which I will click on here to open it up because I want the public IP address, because I want to remote into it to make sure Docker is available within that VM. So here in the overview blade for that VM, I'm going to go ahead and copy the public IP address. I've already downloaded and installed the free PuTTY tool, and I've popped in the public IP of the VM. It's an SSH port 22 connection, so I'm going to go ahead and click Open to open a connection to our newly deployed Docker VM. Because it's the first time I'm connecting to the VM, it asks if I trust the SSH fingerprint. I'm going to choose Yes, and I'm going to authenticate with the user that I specified when deploying it from the template. And I'm going to specify the password also. So that's going to sign me in. So let's just clear the screen and let's just run the Docker command, for example. And immediately we get a return list of the next level commands after Docker, because Docker is installed and ready to go in this virtual machine. An Azure Container Registry is a cloud resource you can deploy so that you can have a centralized repository of container images. To get started here in the portal, I'm going to click Create a Resource in the upper left. We're going to create an Azure Container Registry. So I'm going to search for the word container. And I'm going to choose Container Registry from the list, and then I'll click on Create. I'm going to call this ACR 599, and I'm going to deploy this into an existing resource group. The location will be Canada East. Then I have the option of whether or not I want to enable the admin user, which I can also change after the container registry resource is created. Now I'm going to enable this because it allows for authentication to the Azure Container Registry, such as if I need a host that is running containers, like a Docker host, to be able to publish, let's say, customized images to this container registry. And again, I can turn the admin user on or off after the fact if I wish as well. So I'm going to go ahead and create the Azure Container Registry. So if you go to your notification icon, you'll see it deployment succeeded message. So I'm going to go ahead and click on go to resource to open up the container registry. And here, for example, if I click on access keys, we'll see the name of the registry, the login server, and again, the admin user is enabled, so the username can be used. And either one of these passwords, it doesn't make a difference which one, can be used to authenticate to the container registry. There are two of them because you can regenerate one for security purposes while keeping the other one intact to keep things running. Of course, if we go down into repositories, this is where we would actually see any container repositories that might exist currently in the container registry. Now, if I go back to the access keys, notice the username, for example, is the same name as the container registry, in this case, ACR599. Let's just open up the Cloud Shell here up in the portal. I'll click the Cloud Shell icon. There are some CLI commands that we can issue if we need to get those credentials. So we may as well take a look at how to do that. So I'm going to go ahead and clear the screen here, and I'm going to issue the AZ space ACR for Azure Container Registry credentials show command, and then -- name, and the name of it is ACR599, and I'm going to go ahead and press enter. Well, in this case I have an error because it's credential in singular. I mistakenly added an S, so let's run this once again. And of course, what we can see are the two passwords that we saw in the portal, and of course the username. So it's just another way to retrieve those credentials as opposed to using the portal, which would be required if you wanted to be able to authenticate to the container registry. In this demonstration, I'll show you how to push a Docker image into an Azure Container Registry. I've already authenticated using SSH to a Docker virtual machine I've deployed running in Azure. And that's the command line I'm looking at now. Now, the first thing I'm going to do is log in to my Azure Container Registry, and I can do that using the Docker space login command. But I need to know the name of the server. Well, here in the portal, that's pretty easy to do. I've opened up my Azure Container Registry named ACR599. Under Settings in the navigation bar, I'm just going to go ahead and click on Access Keys, because from here, among other things, I will see the login server name. So I'm just going to go ahead and copy that. Notice by default, the DNS suffix is Azure CR for Container Registry.io. So back here in my SSH session to my Docker VM, I'm going to add that after login, and I'm going to press enter. Now, once a username, well, let's flip back to the portal to get that information. Or, if we know already, which we do, it's just simply the name of the resource that we created in Azure. In other words, the name of the Azure Container Registry, which in this case is ACR599. Then I need to specify a password. Well, we can also get that from back in the portal. We can use either of the two passwords to authenticate, so I'm just going to copy one of them to the clipboard. And I'm just going to go ahead and paste that password in here. And after a moment, we can see that we have logged in successfully to the Azure Container Registry. The next thing I'm going to do is pull down a Docker image from a public repository. So I'm going to use the Docker pull command, and maybe we'll just pull down one called Nginx. Now, of course, this is the Nginx type of public image that we're going to download to run a web app. And notice it's using the latest version of that image. So what I'm essentially doing is downloading it to my local repository. We can just simply run docker space images to see that. And indeed, we can see it has been downloaded. So it's available locally, and from here we could launch containers from that container image. So now I'm going to use the docker tag command to essentially rename that image in my local repository on my local host. I'm going to use docker tag. It's currently called Nginx, and we can see, in fact, that's true. That's how it's listed here. And I'm going to rename it by adding the name of our Azure Container Registry / then the name of it, so Nginx, or I could call it something else. And I'm adding a version here, so I'm going to put :dev. This is the dev version of it, as I want it to be known. So I'm going to go ahead and press enter, and then we're going to run docker space images again. And notice now, we can see that we've got our newly tagged Docker image. So this is the one that, let's say, we would customize, make changes to, and now if we want it available to other developers, we could push it into the Azure Container Registry, which I'm going to do now. So all I need to do is run docker push. I'm going to push over the specific image that we have already just tagged, and it includes the name, the login server name of our Azure Container Registry. And that's important. It has to be done that way for this to work. So I'm just going to correct our syntax here, because all I really need to run is docker push and then specify the newly tagged name. And again, it's no surprise, and it's certainly not a coincidence that the prefix part of the name is the login server name. So that's how it knows where it's going to go, and it's going to be Nginx, and the version is going to be dev. So let's go ahead and run that command. So it's now essentially copying it or pushing it over the network to our Azure Container Registry, which we're going to open up in the portal in a moment because we should see it listed under repositories. And indeed, back here in the portal in our Azure Container Registry in the repositories view, we can see that we've now got an uploaded image. And we can see that the tag added at the end of it was dev. So, in this course, we've examined Azure application containers, including how to use, secure, and manage them. We did this by exploring how application containers can be isolated on different networks. We also discussed how to harden application containers to improve their security posture. We also took a look at the Azure Kubernetes Service, or AKS, and how it provides container cluster services. Then we talked about how to deploy an Azure Docker VM running Ubuntu Linux. We then talked about deploying an Azure Container Registry as an image repository in the cloud, and we talked about how to populate it. In our next course, we're going to move on to exploring Azure Key Vaults and how they are used to safeguard secrets, keys, and certificates for securing resources. Azure Key Vaults are cloud resources deployed in Azure that are designed for secure secret storage. Now, secrets would include things like cryptographic keys, PKI certificates, and passwords. Azure Key Vault is also backed by FIPS 1402-2 Level 2 HSM. That means Hardware Security Module. Now, the reason that this is specified here is because that can be important in some cases for requirements that are stipulated by government agency use of cloud computing. The Azure Key Vault can store keys, secrets, and certificates. Now, these can be imported if you already have them, or they can all be generated directly within the Azure Key Vault itself. You can also restore them from backup. When you work with keys, secrets, and certificates that you generate within the Azure Key Vault, you can set an activation and expiry date and time. Pictured on the screen, you're seeing the Azure Key Vault access policy. Now, as you might guess, this is used to control and limit access to the secrets stored in the Key Vault. So, for example, we've got a couple of check marks to enable access to the Key Vault to Azure Virtual Machines during deployment, or Azure Resource Manager for template deployment, or even Azure Disk Encryption. Down below, we also have an application added called Web App 172. That's an application registered with Azure AD. And you can see for key permissions, it has get permissions, for secret, get, and for certificate, 0. So in other words, Web App 172 will have the ability to retrieve keys and secrets from the Azure Key Vault. To work with Azure Key Vaults, the first thing you have to do is create it. As we've said, it is an Azure Cloud resource. You then create or upload secrets so that the vault is populated with items. Then you configure your apps so that they can retrieve those secrets from the Key Vault. Cryptography is all about security, essentially securing data and protecting it from unauthorized users through the use of mathematical cryptographic algorithms. So cryptography can provide confidentiality of data through encryption, integrity of data to make sure it's not been tampered with, and source authentication to ensure that we know that the data came from who it says it came from, such as with network transmissions. File hashing is one way to determine if a file has changed over time. Email digital signatures are used to assure the recipient that the message really did come from who it says it was sent from. We can use VPN network traffic to protect traffic being sent over the network because it's going through an encrypted tunnel. Blockchain is also another technology that uses hashing. The latest transactions that are added to a blockchain, which happens every 10 minutes out on the internet, are hashed. And they also contain the previous block's hash. So hashing is used with blockchain. When it comes to confidentiality, we're really talking about encryption, encrypting email messages, files, or entire disk volumes, including in the cloud. We can also use cryptography at the confidentiality level by encrypting VPN network tunnels to allow users working from home or traveling to connect over the internet securely to Azure, or to link an entire site, like an on-prem network, to an Azure network. The encryption process begins with the acquisition of an encryption key, and that can come from many different sources. It could be a pre-shared key or passphrase that's been defined, or it might come from a PKI certificate. Either way, the key is fed along with the plain text, the original data we want to protect, into the encryption algorithm, which is essentially a complex mathematical formula. The result is called ciphertext. That's the scrambled data. That's the encrypted data. Now, we've mentioned that hashing can be used for file integrity to detect unauthorized tampering, and it's often used with digital forensic analysis processes to ensure legal admissibility of evidence, to make sure it's not been tampered with, for example, by investigators, such as a seized hard disk from a suspect's location. Often, hashing uses SHA-256 as the algorithm, where SHA stands for Secure Hashing Algorithm. That would be the standard. So the hashing process then starts with feeding the raw data bits into a one-way hashing algorithm. When we say raw data bits, we're just talking about the information. Whether we want to hash a file or hash the result of sending something over the internet to make sure that what was received is the same as what was originally downloaded, so determine whether anything was corrupted or not. So there are many ways that we can feed these raw data bits into a one-way hashing algorithm. So the result on the other side of the algorithm is a hash or message digest. Both of those terms are synonymous. So in the future, when you run that same operation, when you feed the data bits into the one-way hashing algorithm, if the hash that results is different from the original hash, then you know that the source data has been modified, such as a file. But if the hash is the exact same, when you compute it in the future, we know that there has not been a change. Digital signatures use hashing. Essentially, the message content uses a hashing algorithm that results in a hash value or a message digest, whichever term you prefer. For example, imagine that we're digitally signing an email message that we're sending to somebody else. So what happens then is that we get the benefits of integrity. We know that it hasn't been tampered with, the message, the email message. Then that hash value is encrypted with the sender's private key. Now that would come, for example, from a PKI certificate. Now that provides message authenticity. We know that only the sender possesses their private key. And it's also being used to encrypt the hash value for integrity purposes, so we can detect if tampering of the message occurred. So the recipient then can verify the digital signature with the sender's related public key. The public key is called a public key because it can be shared publicly, and there's no security issue with PKI stands for Public Key Infrastructure. Essentially, it is a hierarchy of digital security certificates. The certificates get issued and managed by what's called a certificate authority, or a CA. You can have private CAs with self-signed certificates that you create yourself, or you can use public CAs. Using public CAs is a little bit easier in some cases only because applications such as web browsers are already configured to trust internet public CAs. Whereas if you issue certificates from your own private CA, for example, to secure a web app, web browsers on user devices will not automatically trust that issuer of certificates, although they could be configured to do so. With the PKI hierarchy, at the top, we have the certificate authority, or the CA. In a larger environment, you can have a root CA, and then from it, issue certificates for subordinate CAs. Now, subordinate CAs might be issued for different regions, or different business units, or even different companies under the umbrella of a single parent company. Either way, the subordinate CAs themselves then actually issue certificates, and those certificates could be issued to users, devices, or even to software entities. With the PKI hierarchy, the issuing certificate authority will digitally sign issued certificates. Root CAs, if you're using that type of a hierarchy, should be brought offline when possible, because if the root CA is compromised, so is everything under it, all certificates. But as an example, opposed to that, a compromised subordinate CA means only the certificates issued under that CA are compromised as opposed to all of them. So PKI certificates then are issued by a certificate authority, and they're issued to users, devices, or software entities. And they're issued for many different purposes, such as for encryption, for integrity purposes, and for authentication. So integrity is used to make sure something hasn't been tampered with, like a message sent over the network, and authentication is used to verify that the message came from who it says it came from. Of course, encryption is used to scramble the contents so it cannot be read by unauthorized parties. So PKI certificates could be stored in the file system, in an operating system, even on a mobile device, or they could be burned into a smart card. So what exactly is in a PKI certificate anyway? Well, you're going to have the X509 version number because it stems from the X509 standard. You're going to have the signature from the certificate authority that issued the certificate and the signature algorithm that was used. Every certificate has a unique serial number used for tracking purposes. You'll have the date that the certificate was issued stored within it, as well as when it expires and can no longer be used. The certificate intended use, such as for file encryption. The subject name, which could be a user email address, a device name, or a software entity name. When certificates are issued, they also get a unique public and private key pair, and the public and private key pair are mathematically related. Public keys can be shared publicly with any user or device. That's why they're called public. So the recipient's public key is used when encrypting a message. For example, if I am encrypting an email message I'm sending to you, I need access to your public key, you're the recipient, to encrypt the message for you. Another way that a public key is used is to verify digital signature. If you were sending an email message to me and you digitally sign it so I can be assured it came from you, your private key is used to create the signature, but I need access to your mathematically related public key to verify that the signature is correct. Private keys must be available only to the key owner, and they can even be embedded in cards, like smart cards. So encrypted messages get decrypted using the recipient private key. And as we've mentioned, the private key is also used to create digital signatures. So let's say that we have a need for email confidentiality. Then this can be addressed by encrypting messages with the recipient's public keys. If the need is for email authenticity and integrity, then the solution could be to generate message hashes and encrypt them with the sender's private key. In other words, a digital signature. If the need is to secure network communications to a web server, we could use a PKI certificate configured with TLS version 1.1 or higher. Now, TLS is configured on the client side in the browser and on the web server stack. And then you would enable HTTPS. If you need to use multi-factor authentication through a VPN, then you could even use smart cards with embedded private keys to authenticate to the VPN. If you need a single card for facility and computer access, which is often called a Common Access Card, a CAC, then you could use that with an embedded private key. So the PKI lifecycle begins with the certificate being issued by a certificate authority, the certificate being used, and the certificate either being renewed before it expires, or it will expire when it no longer can be used, or the certificate might be revoked due to a security compromise. Secure Sockets Layer, or SSL, is a network security protocol. However, it really shouldn't be used these days in the interest of security. It's deprecated due to its known vulnerabilities. Now, when SSL is used, it requires a PKI certificate, which is often incorrectly referred to as an SSL certificate. That's not quite correct because it's a PKI certificate that could be used for SSL or its successor TLS. A PKI certificate, for example, might be issued to a user for the purposes of that user being able to encrypt and digitally sign email messages, or a PKI certificate might even be issued to a web server so that you could secure connections to it over HTTPS. Now, because SSL is deprecated due to its security issues, it should not be used. And so you can disable SSL, for example, in the enterprise on the client side in the web browser. You can also disable it server-side in the web server stack. So really, stay away from SSL where possible. Instead, you should opt for Transport Layer Security, or TLS, which supersedes SSL and again, uses a PKI certificate. We're not calling it an SSL certificate. We're not calling it a TLS certificate because those are misnomers. It's a PKI certificate. Sometimes you'll hear people call it a digital security certificate or an X509 certificate, all of which are valid. Now, TLS version 1.0 has had its share of security vulnerabilities, and so it's considered deprecated. What that means is you should never use TLS version 1.0. You should start at 1.1, ideally all the way up to 1.3, the latest incantation of the TLS network security protocol. Again, just as is the case with SSL and disabling it, to configure the version of TLS that will be used, you can configure it client-side, for example in the web browser, and server-side in the web server stack. So to harden your enterprise, you really should be doing this. You should have a centralized way to configure these settings on all web browsers and all web servers. Now, securing network traffic, for example, through the use of TLS version 1.1, is sometimes required by laws, regulations, or certain security standards like PCI DSS. That is really used to secure cardholder information for Visa, MasterCard, American Express. Now, when you secure network traffic using a PKI certificate, it can be used for different apps. It does not have to be a web application for HTTP. Certainly that's common and very important. But you could also use it for Secure Multi-Purpose Internet Mail Exchange, or SMIME. In other words, to secure internet mail transmissions. Again, it uses a PKI certificate, and it's used to encrypt and digitally sign email messages at the transfer level as opposed to the individual user level. In this demonstration, I'll be using the Azure portal to create a key vault. An Azure Key Vault is a cloud resource that you deploy that's used to store secrets, like passphrases or encryption keys or PKI certificates that you either import or generate directly in the Key Vault. So to get started here in the portal, I'm going to click Create a Resource in the upper left, and in the search bar, I'm going to search for Key, and right away I can see Key Vault. That is what I want. Then I'll choose Create. As is the case when we normally deploy any cloud resource in Azure, we'll have to specify some details, such as the subscription it's tied to, the resource group it will be deployed into, and of course the name of it. I'm going to call this KV for Key Vault 444. So Key Vault 444. Then I can specify the Azure region where I want that deployed. So I can choose that from the list. I'm going to choose Canada East here. And I'm just going to go ahead and click Next for the access policy. Here we can determine which specific applications, so we can add an access policy, that are registered in Azure AD, have access to secrets inside the vault. You might have an app that has a component that needs to read maybe a passphrase to access a backend database. Or you might want to enable Azure virtual machines access to this for disk encryption purposes if the encryption key used for encrypting Azure disk volumes is stored in this key vault. Either way, I'm not going to actually make changes to that. I could click Next to Virtual Network and control access to this key vault from specific virtual networks. Notice the default is it's allowing access from all VNets. That's fine. I'm just going to go ahead and click Review and Create. The validation passed. Let's create the key vault by clicking the Create button. And before too long, it'll say your deployment is complete. We can click Go to Resource to open up the key vault. In the key vault, we'll have a section where we can either generate or import keys, so encryption keys. We can create secrets, so generate or import secrets like passphrases. And the same thing is true for PKI certificates, generate or import them. Here's the access policy that we could have configured upon creation by allowing access to registered apps in Azure AD, and also the firewall and virtual networks limitation, which is set to all networks by default. In Azure, key vaults are a separate cloud resource you deploy to store secrets, like passphrases, PKI certificates, even encryption keys. And these can be used by a wide variety of uses, such as encrypting Azure virtual machine disks, or you might have an application registered with Azure AD that needs to retrieve a passphrase before it can access a database, stuff like that. Well, you can create and manage key vaults using the CLI. And so here in the portal, we're going to launch the CLI this way. We're going to go into the Cloud Shell up at the top. Now this is as opposed to downloading and installing the CLI on our on-premises system. So I'm going to maximize the window, and I'm going to make sure that we're either in PowerShell or Bash. It really doesn't matter to access the CLI. You can do it from both places. And what I'm going to do is use the AZ key vault syntax. Now, if I don't know what to use after that, I can ask for --help, and it'll tell me the next level command to use in the syntax. In our case, it probably seems like we want to create a key vault, so create would be next. So we then end up with AZ key vault create. I'll use --name to specify a name of KV445. I will use --resource-group to specify the resource group to deploy this vault into. In this case, that's going to be AZ-500. And I'll use --location to specify location of Canada East. So let's press Enter to create this Azure Key Vault. And after a moment, we can see the Key Vault was deployed. So at this point, I'm going to run AZ Key Vault list, and I'll press Enter to list the key vaults in our subscription. Now at the same time, we could also, of course, go to our All Resources view here in the portal, and we could filter by key vaults. So I'm going to click Type, I'm going to uncheck Select All, and we care about key vaults, so I'm going to choose the key vault selection box, click outside of it, and what we're looking for in this case is KV445. That's the key vault we just created using Azure CLI commands. You can use PowerShell to create an Azure Key Vault to store secrets like passphrases, encryption keys, and PKI certificates. So here in the portal, I'm going to launch the Cloud Shell from the Cloud Shell icon up at the top. I'm going to make sure I've got a PowerShell session started, and I'm going to maximize the window. To do this, I'm going to use the new -AZ Key Vault commandlet. Now I'm going to have to use the -resource group name to specify the resource group I'm going to deploy this into. Certainly, I'll need to use -name to specify the name of the key vault I want to create, in this case, KV Key Vault 446. And I'm setting the -location parameter to Canada East. Let's press Enter. Let's see what happens. Now what's going to happen is it's not going to be a surprise. It's going to create a key vault. Let's clear the screen, let's say with CLS, and let's run get-AZ key vault to retrieve a list of key vaults. And if we take a look at our key vaults, now we might have to scroll back up, but we should eventually see KV446. Now, of course, we could also have filtered the list. So let's just clear the screen. Let's use the up arrow key to get the AZ key vault again, and then I'll pipe that to select, where we could ask, for example, for the vault name property. And then that way, that's all we're looking at, instead of all the other stuff that we might not care about. Every Azure Key Vault has a Key Vault access policy. And as you might guess, it determines what kind of access is allowed from other virtual networks to the resources in the Key Vault, and also by which applications that might be registered in Azure Active Directory. So let's go ahead and set an Azure Key Vault access policy here in the portal. To do that, I'm going to open up an existing Key Vault named KV444. When I click to open that up, in the navigation bar for the Key Vault, if I scroll down a little bit, you'll see down under settings that we've got access policies. So I'm going to click to open the access policies blade. Now there's a couple of quick and convenient ways to allow access to the vault here. We can allow Azure Virtual Machine Deployment access to the vault, Azure Resource Manager for template deployment of resources if they need to access keys, secrets, or certificates, and of course Azure Disk Encryption to encrypt Azure Virtual Machine disk volumes. That would require access specifically to keys, encryption keys. We can also click the Add Access policy, and when we do that, we can configure from a template. So what might we need here? We might need SQL Server connector access to be allowed. So it automatically knows that 4 permissions are required for that one. How could it know that? Well, if you think about it, you'll see it when you open it up. It would allow the retrieval or the getting of a specific key stored in the vault, the listing of keys, and also the ability to unwrap and wrap keys. Now, if we were to choose some of the other items, such as Azure Backup, 3 permissions are selected, at least at the key level: get, list, and backup. And then there are some secret permissions that are set here: get, list, and backup. You can think of secrets as being kind of like passphrases, but 0 certificate permissions. So you can add the appropriate access policy. It could even be a custom one if you really want it to be. So I'm going to choose here SQL Server Connector to go back to that. I can also further specify the backup management service, the principal that I'm giving this access to, and that will change depending on what you select here for the access policy. So let's say I just choose key management. So from here again, we could choose the appropriate backup management service item, the principal. Now from here, we could search by name or email address, and from here we can go through, and what I'm really doing here is I'm looking through Azure Active Directory. I'm looking at groups, users, also looking at apps, for example, a billing app that might require that access. So we can do that as well. Now when I click Authorized Application, it says None Selected, and that option is locked. The Authorized Application option is only applicable essentially as a proxy, meaning that you want an application to use user access permissions, so to do things on behalf of the user permissions that are granted to the user. In this case, I'm going to click Add, and we can now see that we've got a new access policy added here for the billing application. So to finalize it, we just need to click Save. You can use the Azure portal to create or import keys, cryptographic keys that might be required by software components or applications that might be registered in Azure AD. So I'm going to go ahead here in the portal, in the All Resources view, where I've already filtered for only key vaults, and I'm going to open up an existing key vault named KV444, because I'm going to create or generate a key. In the navigation bar, I'm going to click on Keys, and any existing keys will be shown. It says there are no keys available. So I'm going to click the Generate Import button at the top. Now from here, from the options drop-down list, I can choose to generate an encryption key, import it, or even restore it from backup. But in this case, I'm just going to generate one, and I'm going to call it Key 1. Now I might be generating this key for a multitude of purposes. Anywhere you might need a key for encryption or decryption. For example, I might do this if I need a symmetric key to encrypt an Azure Virtual Machine disk volume. So I can select the key type, RSA or EC, and the key size. I'm going to leave it as RSA 2048 bits. I can also set an activation date of when this key can be used. It doesn't have to be now upon creation. And also an expiration date. If I don't specify it, it never expires. And it's going to be enabled by default. That's set to yes. So I'm going to go ahead and click Create. And we can now see that we've got a key named Key 1 that's been enabled. It's stored in our key vault. And depending on our access policy for the vault, so for example, if I go to Access Policies, this is where we can determine who or which applications have access to keys in the vault. So other than adding an access policy to specify those permissions, so if I were to click Add Access Policy, here we could choose from a template, or we could just start saying I want certain key permissions, like listing and retrieving or getting keys to be available. Instead of doing that, we could also enable it up here if applicable, such as to allow key access by Azure virtual machines for the purpose of volume encryption. In this demonstration, I'm going to use the Azure CLI to create an encryption key stored within an Azure Key Vault. Now I'm going to choose to create it, but you could also import keys from an existing security certificate. Here in the portal, I've clicked the Cloud Shell icon to launch Cloud Shell. The syntax is going to be AZ Key Vault Key Create. I'll use the --vault-name parameter to specify the name of the vault in which I wish to create the key. So the name of the vault is KV444 in this case. I'll use --name and specify that I want this key to be called key2. And I've also specified --protection with a value of software. That means I want the key protected at the software level as opposed to using HSM or a hardware security module. So I'm going to go ahead and press Enter to create that key. And it looks like it's already created. Now we have a couple of ways that we can verify our work. One of the ways we can do it is to run AZ space key vault space key space list --vault -name, in this case KV444. And that'll show me any keys that might exist already within that vault. So we can see all the details listed here, all the properties, I guess you could say, for each of the keys. But we could also look at it here in the GUI in the portal. So if I open up KV444, and if we click on keys, we'll see our newly created key, key2. In this demonstration, I'll use PowerShell to create a new key inside of an Azure Key Vault. Now we're talking here about adding an encryption key. So the first thing I'm going to do is create a variable that determines when the key will expire. So to do that, I'm going to create a variable called $expires, which will result from running getDate, which is in parentheses because I want that treated as a separate commandlet. Then I'm going to call upon the .addYears property, or method rather, and I'm going to add 1 year. Now that means I want the certificate to expire a year from when it's generated. And I'm then going to call upon the .toUniversalTime method so that it's referenced in universal time, UTC. So I'm going to go ahead and press Enter, and if we take a look at the $expires variable by simply typing in the name of it, pressing Enter, we can see it's set to be 1 year from today, because today is November 9th, 2019. So I'm going to clear the screen, and the next thing I want to do is specify a variable that determines when the key will be usable. So I'm just going to call it not before, so $not before, because in PowerShell, variables are always prefixed with the $. Again, getDate is listed in parentheses, so it's treated as a separate commandlet, and I'm going to call the .toUniversalTime method. And if we take a look at that variable, so $not before, Enter. Okay, so today it's picking up the current date and time. It can't be used before that. Perfect. So really, all we have to do now is add the key to the vault using those two variables. So I'm going to call upon the add-az key vault key PowerShell commandlet. I'll use -vault name and specify I want to create a key in a vault called KV444. I'll use -name because I want to call this key key3. The destination parameter has a value of software as opposed to having the key protected by hardware through HSM or hardware security modules. I'm going to specify -expires, and here's where I'm going to use my expires variable for the expiry date of the key. It's only good for a year in our particular example. And the -not before parameter and our $not before variable. Let's go ahead and press Enter to build the key. Now it's very quick. Looks like it's good to go, but why don't we check our work back here in the portal where I've already opened up that key vault. So in the navigation bar for it, I'm going to click on keys, and there it is, key3, the one that we've just created through PowerShell. You can use the Azure GUI to create secrets within an Azure Key Vault. Think of a secret as being like a passphrase that might be required by app components to access another resource like a backend database. And so the apps would have to be in the Key Vault access policy with access to retrieve or even list, depending on how you're using it, those secrets. Okay, let's get to it. Here in the portal, I'm already in the All Resources view. I've already filtered it for only key vaults. I'm going to open one up called KV444 because that's the vault in which I want to create a secret. So I'm going to click Secrets in the navigation bar where I can generate or import secrets. So if I look at the upload options, it can be manual or from a certificate. I'm going to leave it on manual. The name here will be Secret 1. And for the value, I'll just enter some variation of a sample password. And I can set an activation date. Let's go ahead and do that in this case. When should this be usable? Even though I'm creating it today, November the 9th, I don't want it available today. I only want it available starting next month. So let's say starting on the first Monday in December. And I can specify the time of day as well and the time zone. And I can also set an expiration. So let's say we know this secret is going to be used for dev testing for the first week of December. Well, let's set an expiration date. That would be the prudent security thing to do. So I'm going to go and click on the calendar selector and specify the end of the first week of December. So I'm just going to make sure I'm in the correct year. That would help. And after I've done that, I can also specify the time and the time zone when that should expire, which means it can't be used, of course, after the expiration date. And I'll go ahead and click Create. So now we can see Secret 1 exists. Now don't forget about the access policy for the whole vault, where you might add an access policy where you could either choose from a template or specify your own secret permissions. So getting or retrieving specific secrets, listing, setting, deleting, recovering, backup, and so on. When you do that, you have to select the security principal to which that applies. So you can select from Azure AD, whether it's a group or an application or a user. The Azure CLI can be used to manage anything inside an Azure Key Vault, including secrets, which in other words are really like passphrases. So in this case, I'm going to create a passphrase for a database and store it as a Key Vault secret. I've already launched the Cloud Shell here in the portal, and I'm in a bash environment, and so we're going to access the CLI from here. Technically, the way we're going to run the commands, it could be bash or PowerShell. The CLI is available in both. The only thing to watch out for is, for instance, if your command set or your syntax refers to anything specific to Linux, well, then you would have to use bash. Anyway, let's get to it. So here I'm going to use the AZ Key Vault secret set command syntax. I'm going to specify --vault-name. So I want to create this secret in a vault called KV444. Now I have to give a name to the secret, so I'll specify that with --name, and I'm going to call it DB passphrase. Of course, I have to set a value for it. So --value, and in quotes, I've got the passphrase, which presumably will be used to access a database. So let's go ahead and press enter to create this secret. Before you know it, it's done pretty quickly. So what we could do is clear the screen. We could use AZ space key vault space secret space list. Of course, I have to tell it the vault, so --vault-name, KV444 is the name of it. Now, always remember it's going to return all of the properties available when it comes to listing these items. But that's fine, it is working. Also, we could view it back here in the portal. If I look at my key vault, and if I were to look at secrets, well, there's the DB passphrase secret. Azure Key Vault secrets are essentially passphrases that we can store or import in the vault. Now we're going to generate one in this example using PowerShell. Here in the portal, I'm going to launch the Cloud Shell, where I've already got a PowerShell session running. I'll just clear the screen. And the first thing we're going to do is establish a secure variable for the passphrase. To do that, I'm going to create a variable called $secret. I'm going to run the convert to -secure string commandlet, where the string is going to be what I want to be the passphrase. So it's a variation here on password ABC123. And I'm going to use the -as plaintext and -force parameters. That will establish our variable. So if I run $secret to take a look at the variable, we can't even see it. That's the point. It's treated as a secure string. So the next thing we have to do is actually apply that to a key vault secret that we create. To do that, I'm going to call upon the set-az key vault secret commandlet. I'll use -vault name and specify the key vault where I want to create the secret. It's going to be KV444. -name, specify the name of the secret, which I'm calling secret2, and then the -secret value parameter. And of course, I'm going to pass it the $secret variable, which is now treated as a secure string. And if we just minimize that and go and take a look here in the portal, let's say at KV444, and let's go to the secrets blade, indeed, we now see the existence of secret2. Certificates are used in IT computing environments for security purposes, if we can just say it that way as an umbrella generalized statement. Now we're talking here about digital security certificates, otherwise called PKI certificates or X509 certificates. You might need one on your smartphone, for example, to authenticate to a VPN. You might have one on your web server to secure communications to the web server. You might use a certificate so you can encrypt files on your hard drive. It could be any number of possibilities, even for digitally signing and encrypting email. Well, in the Key Vault, we can import existing certificates if we already have them, or we can generate our own, which is what we're going to do. Here in the portal, I'm already looking at a filtered list of objects in the All Resources view. I'm filtering it by key vaults. And I'm going to open up KV444. It's an existing key vault. And I'm going to click on certificates in the navigation bar. You'll see any existing certificates, but you can also click the generate import button. And from the method of certificate creation, you can either generate one, which we're going to do, or actually import one from the file system. So you'll have to specify the location and name of the certificate file. And if it's a private key type of certificate file, you need to specify the password to be able to gain access to it. Let's close that. What I want to do is click Generate Import again, and this time we're just going to leave it on Generate. I'm going to call this Cert1. Now you might wonder, why would I do this? Why would I make a certificate? Well, let's say that you've deployed an Azure web application with a custom DNS domain name, and you want to apply TLS, so you want to secure communications with your custom DNS name. You need a certificate to do that. And if you don't already have one, this is one potential way to do it. There are many others. So for the certificate authority or the issuer of the certificate, you could choose an integrated or non-integrated CA, so a third party, but in this case, I'm going to choose self-signed certificate. Now beware, when you issue certificates that are self-signed, it means that client applications like web browsers will not automatically trust it because they don't trust the issuer. Now you can modify that, but that is the default behavior, just be aware. So the subject here, well, let's say it's for a website. Common name or CN equals www.mysite.com. Then we can click on DNS names, and this is the alternative name. Again, normally it's the same, www.mysite.com. Now that has to match, for example, the custom DNS domain name you're using for your web app. Otherwise, you won't be able to enable the TLS binding. The validity period is 12 months. Perfect. I'm going to leave the default content type, and I'm going to click Create. So we can now see Certificate 1 or Cert1 exists. Now notice at the top here, we also have certificate authorities. Here we can add CAs or certificate authorities, including third party. Now again, these are issuers of certificates. You have to have subscribed to them. Now the big ones out on the internet that are trusted automatically by client apps like web browsers are certificates issued from DigiCert or GlobalSign. So we can also add that information here if we have a subscription for those publicly trusted CAs. And of course, don't forget about the access policy here for the Key Vault. You might add an access policy, for example, and either choose from a template or specify specific certificate permissions that would be applicable to security principles, which you could select down here, be that a user, a group, or an Azure AD registered app. In this demonstration, I'm going to use the Azure CLI in the portal through Cloud Shell to actually create a new PKI certificate. So to get started here in the portal, I'm going to click on the Cloud Shell icon. I already had a Cloud Shell session running for Bash, so I'm going to go ahead and build a new certificate. To do that, I'm going to use the AZ Key Vault Certificate Create command. I'll use the --vault-name parameter to specify the name of the vault in which I want to create this new certificate. It's called KV444. The name of the certificate with -n is going to be cert2, and I have to specify a policy. So here in quotes and a $sign and open parentheses, I'm running AZ Key Vault Certificate get-default-policy, close parentheses, close quotes. So I'm just going to retrieve the default policy and apply it to who and what is allowed access to this certificate. Now remember that if you're going to be using anything in your syntax that's specific to an operating system, so referring to, in this case, variables in such a manner that would be parsed properly by a bash shell, well, you'd better make sure you've got a bash shell selected here if you're in Cloud Shell. Even though you can switch to PowerShell and still run CLI commands, which is true, some of the syntax, like what we've got here, is not going to work properly. So that's why I have to make sure sometimes I'm using a bash shell, which I've done here. Okay, let's press enter and let it build the certificate. We're going to check our work afterwards in the portal. Okay, looks like we've got a lot of public key information here for the certificate, all kinds of goodies. That's the certificate signing request information, or CSR. Let's double check our work here in the portal. So I'm already in the key vault. Why don't we click certificates? And there it is, cert2. A self-signed signature. In other words, it's not going to be issued from a trusted third-party public certificate authority. So the first thing I need to do is determine the policy for how the key will be used, its validity period, so how long before it expires, and so on. To do that, I'm going to create a variable called $policy, and from that, we're going to run the new-AZ Key Vault Certificate policy, whose return result will be stored in the $policy variable. So when we use new AZ Key Vault Certificate policy, we can specify the content type. So -secret content type, this is going to be a PKI certificate. The -subject name uses the common name notation, CN equals, and I'm putting www.site.com. That's going to be used for a website. The issuer is going to be self. It's a self-signed certificate. The validity period, validity in months, is set to 12. And on renewal, if we renew the key before it expires, we can just reuse the keys within the certificates. So I'm going to press enter to set that variable. Now the next thing we have to do is actually create the certificate in the key vault and use this policy. To do that, we'll run add-az key vault certificate. We're creating a new certificate as opposed to importing one. I'm going to use -vault name and specify the vault name in which I want the new certificate created. So that's KV444. And the name of the new certificate with -name will be site2cert. And then I'd simply use the -certificate policy parameter and pass it the variable I established up above. Let's go ahead and press enter. So we're going to check our work here. Let's minimize Cloud Shell. And here in our key vault, why don't we go to the certificates view, where we will see that we've got site2cert. Now currently it's in progress, so if you wait long enough and refresh, after a moment it'll show up under completed as opposed to in progress, failed, or cancelled. Sure enough, if I refresh again, we can see that it is enabled and it's showing up under completed, so it's ready to go. So, in this course, we've examined the Azure Key Vault, its use, and how to implement Key Vault secrets, keys, and certificates for securing resources. We did this by exploring the purpose of the Azure Key Vault. We talked about how cryptography relates to data security. We talked about public key infrastructure, PKI, and the certificate lifecycle. We also talked about secure sockets layer, SSL, and its successor, transport layer security, or TLS. Then, we talked about how to create a key vault using the GUI, the CLI, and PowerShell. We talked about configuring a key vault access policy to control access to items in the key vault. And then we created items in the key vault in the form of creating keys, secrets, and certificates. In our next course, we'll move on to explore the use of both role-based access control, or RBAC, and policies for controlling access to Azure resources. Azure Role-Based Access Control, or RBAC, is all about delegated access control. So the idea is that you can delegate the management of Azure Cloud resources to other administrators. And you can do this using either built-in roles or custom roles that you create to suit your needs. Now, there's a lot of built-in roles in Azure. Here's a few examples. One is the owner role. If someone has the owner role, it means that they can fully manage that cloud resource in its entirety. Whereas the contributor built-in role allows resource management other than changing RBAC access itself. The reader role, as it implies, provides read-only access to the resource. CDN endpoint reader is for content distribution networks. It allows read-only access to CDN endpoints. The cost management contributor allows reading and writing of Azure cost configurations and budgets. And the virtual machine administrator login role allows administrators to read VMs in the portal and then log in with admin credentials. So bear in mind then that a role is really just a collection of related permissions. Now, when you want to build your own custom roles, the process starts with creating a JSON role file. JSON is the syntax used within a standard text file. After you've defined that role, the next thing is to actually create a role from it in the Azure cloud. And you can do that, for instance, from PowerShell using the new -AZ role definition commandlet. And you can also do it using the CLI, using the AZ role definition create command prefix. Pictured on the screen, you'll see an example of a sample custom RBAC role file. And this is using the JavaScript object notation, or JSON syntax, where we've got the opening curly brace, beginning of the file, and a closing curly brace at the very bottom. Notice that the name of the role, as it will be created in Azure, will be custom VM role. Following that, we have a unique ID for the role. We have set the is custom flag to true because it is a custom role. We've specified a description for the role, and also we've got a number of actions. These are the permissions that the role consists of. So the ability to read all storage items in Azure and network and compute items, and then for virtual machines having the ability to start and restart them. Now, you can assign RBAC roles to users. These are Azure AD users or Azure AD groups, or service principals. Essentially, think of a service principal as being like a user account, except it's used by a software application. And some services in Azure are managed, including the identities that need access to other resources. And so you might see managed identities in Azure AD that you can select as well for role assignments. And then you have to think about the scope where the role will be applied. And that can be done at the subscription level. So if you apply a role assignment to the subscription, that assignment applies to everything in the subscription. It flows down, or it's inherited by all of the resource groups, and by extension, all of the resources in those resource groups. But you can be a little bit more granular. You might set the assignment scope for RBAC roles only to a resource group. That way, you might want certain administrators to only have the ability, for example, to manage virtual machines deployed in one resource group and one resource group only. And you can get very granular, and you can actually set the assignment scope to a specific resource, such as an individual virtual machine that you want to allow an administrator to manage. Pictured on the screen, we have an example of inherited RBAC permissions. So what we're looking at is a screenshot of looking at the navigation bar or the properties for an Azure resource group. And what's been selected on the left is Access Control IAM, where IAM stands for Identity and Access Management. That's where you go when you want to either view or set role assignments, in this case, resource group. Well, if we look to the right in the screenshot, we see the first listed role called Network Contributor, and it was assigned to the Central Region Canada group, and it's assigned at this resource, as it says in the rightmost column. However, below that, the owner role applies to this resource group for the Azure Admins group. However, it was inherited from the subscription. It wasn't set at this particular resource. So we can quickly see these things in the portal when we're working with RBAC role assignments. In this demonstration, we're going to create a custom RBAC role. Here in WordPad, I've got a custom RBAC role file definition using the JavaScript object notation or JSON syntax. So we can see the opening curly brace at the very beginning of the definition for the role. And if we look down at the bottom of the file, you'll see that there's a closing curly brace. Now within that, we've got our definition for our custom role. We can see the name will be custom VM role. It's got a unique ID that we are assigning to it. The isCustom attribute is set to true. We've got a description for the role, and then we've got some actions. In this case, the ability to read all storage objects, all network and compute objects. And for the Microsoft.compute/virtual machines items, we have the ability to start and restart virtual machines. So as we scroll down further, you can also set the assignable scopes, for example, to a subscription level. So we've got the definition of our custom role here. So let's actually work with this to create it, so then we'll see it, for example, when we go to assign roles, even through the portal. Here in the Azure portal, I'm going to go into the Cloud Shell, and I'm just going to maximize the window. And the first thing I need to do is just click the Upload and Download Files button, because I want to get that custom role JSON file here in Cloud Shell in the file system, so I can actually use it to create the role. So I'm going to click Upload, Download Files. Then I'll choose Upload. And I've selected the custom role JSON file, and we can see it's uploading it to the /home directory for this user account here in Cloud Shell. So if I press, or if I type CD, enter, it automatically switches me to the home directory for the logged in user. And if I do a dir, there's our custom role JSON file. So what we're going to do is use the new -az role definition PowerShell commandlet to create a new role. I'll use the -input file parameter, and in quotes, I'm going to put in the name of our file, custom role.json. And I'll close the quotes, and I'm going to go ahead and press enter. And after that, we have some good output here. Our new role, custom VM role, has been created. So let's check that out in the portal. So I'll minimize Cloud Shell. Let's say, for example, we want to assign to the resource group scope. So I'm going to select an existing resource group. I'm going to go to the Access Control IAM blade, and we're going to go ahead as if we were going to actually assign the role. So I'll click Add, and I'll choose Add Role Assignment. We know it's called Custom VM Role. I can just type in cust, let's say, to filter the list, and there it is right away. So we've now successfully created our custom RBAC role. You can use the portal to assign RBAC roles, whether they're built-in or custom roles, at the subscription, resource group, and individual resource level. Let's take a look at how that's done here in the portal. So to get started, in the top center search bar, I'm going to search for the word sub, and then I'll choose subscriptions. This will show me any subscriptions associated with my Azure account. I've got one called Pay As You Go. So I'm going to go ahead and click on it to open it up. And I'm going to click Access Control IAM in the navigation bar. Now here, over on the right, I can click Role Assignments, and I can see any roles that were assigned at this particular level, the subscription level. And I can even filter it out. For example, if I'm only interested in the backup contributor role, I can select that, click outside, and now it's filtered to only show me the backup contributor role, which in this case was set for the Azure Admins group at this resource, the subscription level. So the members of the Azure Admins group in Azure AD will have the permissions stemming from the backup contributor role everywhere for all resources in the entire subscription because it flows down. It's inherited after you assign it at this level. So we could also click Add up the top and add a role assignment, which I will do. We're going to add an assignment for a custom role named Custom VM Role. And for the security principal, I'm going to select Azure Admins, and I'll click Save. Now that's an Azure AD group that I've created previously. Now, of course, at this point, if we were to refresh the screen, and if we were to take a look down through the list of roles, we'll see Custom VM Role has been set for the Azure Admins group at this resource level. Again, this is at the subscription level, so it's been done. So let's go down into the resource groups view here in the portal. I'll click that on the left. I'm going to open up an existing resource group, and I'm going to click the Access Control IAM item. And of course, we could add role assignments here. However, I'm going to click Role Assignments so we can check out the inheritance from above. So what I'm going to do then is filter out all the other roles. All I want to see here is a custom VM role. And we can see that that was inherited from the subscription. And if I click Overview here, because this will show me the resources deployed into this resource group, we can see them down here over on the right. If I click on any one of those, like the Azure Container Registry, and click Access Control, and if I were to look at the role assignments for this individual resource in that resource group, let's filter out the role again. So I'm going to deselect everything. All I want to see in this case is Custom VM Role. Sure enough, we see it again. It applies even here because it was inherited from the subscription level. In this demonstration, I'm going to configure an RBAC role assignment using the Azure CLI. And before we jump into the Cloud Shell to access the CLI here through the portal, I'm going to go ahead and take a look at Azure Active Directory. So I'll click that over on the left-hand side because I'm going to end up assigning a role for a specific group, and I need the group ID. Now, the group ID, of course, can be acquired in the CLI as well, but we're just going to do it here. So I'm going to click Groups. That'll show me all the groups here in Azure AD. There's one here called Azure Admins. And if we take a look on the right here, we're in the Overview blade. There's the object ID. I'm just going to go ahead and copy that to my clipboard. Now let's go into the Cloud Shell. So I'm going to launch Cloud Shell, and we're going to work with the CLI from here. I'm going to use the AZ role assignment create command prefix to assign a role, so I have to tell it some additional information. I'm going to use --role and tell it I want to assign the reader role. I'm going to use --assignee, and this is where I've placed the object ID for the Azure Admins group that we viewed previously. And I want the scope for this role assignment to be at the resource group level. So I'm telling it that by using --resource-group, and I'm giving it the name of the resource group, in this case AZ-500, where I want that applied. So I'm going to go ahead and press Enter. Now we're going to check our work here in the portal. Why not do that? Let's go to the AZ-500 resource group to see if the Azure Admins group is assigned with the reader role. So I'm just going to minimize Cloud Shell. We're going to go into the resource groups view over here on the left. And of course, on the right, I'm going to select the AZ-500 resource group. Let's click Access Control IAM. And then we're going to click Role Assignments. And of course, we're going to filter out the list, so we don't have to look at everything else. So I'll click right on Role, uncheck Select All, and we're going to select Reader, click outside. And after a moment, we scroll down a little bit. Indeed, there's the Azure Admins group with the reader role that was set at this resource level. Now we can also delete role assignments using the CLI. So why don't we go ahead and do that? Of course, we could also select it from here and remove it, but we're going to do it from the CLI. So I'm going to go back into the Cloud Shell, and we'll start by clearing the screen with CLS. So the command's going to be AZ role assignment delete. I'll specify --assignee, and again, there's the object ID of that group in Azure Active Directory. And the role in question here that was assigned that we want to remove is reader, so --role reader. And this is for a resource group, so I'm using --resource resource-group, and I'm specifying the resource group where I want that role assignment removed. So I'm going to go ahead and press Enter. Should only take a moment. Looks good. Let's minimize it. Let's check our work. So back here, I'm just going to click the refresh button in the portal. We're still at the same screen. And let's once again deselect everything other than the reader role. And when we take a look at the reading role, we can see that we no longer have a listing for the Azure admins group. In this demonstration, we're going to take a look at how to work with RBAC roles using PowerShell commandlets. Here in the portal, I'm going to start by launching Cloud Shell. So I'm going to click the Cloud Shell icon at the top. First thing that we're going to do is just get a list of commands related to role assignments and removals and so on. So I'm going to type get-command, and I'll use an asterisk. I'll put in AZ role and another asterisk for wildcards. And we can see we have a number of commandlets. So we can get role assignments. We can even get role definitions. We can make new role assignments. We can create new role definitions. That's for custom role creation. We can remove role assignments and definitions or modify it using set-az role definition. Okay, I think we have a sense of what we can do. Let's go ahead and use some of those commandlets. First thing I'm going to do is establish a variable called $user, and it's going to contain in quotes the user's sign-in name for one of my Azure AD user accounts. So I'm just going to type in $user after having pressed Enter just to make sure it took, and it did. So what I'm going to do now is run get-az role assignment. We saw that was a commandlet. And what I'm going to tell it is I want to specify the sign-in name. So -sign in name. And I use our variable, $user. So I want to see any roles that were assigned to C. Blackwell. Now, after a moment, if it doesn't return anything, it means that there are no role assignments. So let's go ahead and add a role assignment for that particular user. So I'm going to do that, let's see, by adding a role assignment in the portal. So I'm going to minimize this. I'm going to go to my resource groups view. In this case, we're going to assign it at the AZ-500 level. I'm going to click Access Control IAM over on the left. Add role assignment. And in this particular case, why don't we assign the custom VM role? That's a role that I've created already. And I'm going to specify user C. Blackwell. So Cody Blackwell, save, and it's done. Now, of course, if we go back here in the portal, into the Cloud Shell, and if we take a look at the commandlets that are available, we could have used the new -az role assignment commandlet to do that as well. However, here, we're going to run the get-az role assignment again for that user. And this time, notice that Cody Blackwell has an assignment specifically for the custom VM role. And specifically, the scope, as we can see here, is not for the entire subscription, but rather for the AZ-500 resource group. Now, we can also remove role assignments here using PowerShell. Of course, we can do that in the portal. But let's do it here in PowerShell. So I'm going to go ahead and clear the screen. So I'm going to use the remove-az role assignment commandlet. I'm going to use the -sign-in name parameter and give it our $user variable as our user sign-in name. I'm going to use the -role definition parameter. And the role that we want to remove is custom VM role. That's what we assigned in the portal a moment ago. And it's for the resource group. So -resource group name AZ-500. Let's go ahead and press Enter. Now, if we use the up arrow key to go back to the get-az role assignment for this particular user, once again, we get nothing because we've removed it. Now, let's actually do something else. What about removing custom role definitions? We can do that using PowerShell. So here I'm going to use get-az role definition, -name is custom VM role, and I'm going to pipe that using the vertical bar symbol. That's the piping symbol. So take the result of the command to the left, pipe it to the one on the right, which is simply remove -az role definition. I'm going to go ahead and press Enter. It asks if I'm sure. I'll choose yes. Now, in this case, it says you have some existing role assignments. So therefore, you can't delete this custom role definition until you've cleared that up. One way to get a list of where that role was assigned is to use the get-az role assignment. I'm just going to pipe that to the where alias, so that's my filter, and my expression for filtering is enclosed within an opening and a closing curly brace. So I'm using the $_ built-in PowerShell placeholder variable because it's going to need to cycle through all of the role assignments. So this is my temporary variable for that. And I'm calling upon the .role definition name property to see if it equals what we're looking for here, custom VM role. Let's go ahead and press enter. Aha, so now we can see that the Azure admins group was assigned the custom VM role at the subscription level. And so that's the problem. We can't remove that role because there is an assignment. Now we can remove the role in a multitude of ways. I'm going to minimize Cloud Shell. We're just going to do it here in the portal. So I'm going to go to subscriptions for my account. I'll open up my pay-as-you-go subscription, because we know that's where the role assignment was applied. And we'll click Access Control. And if we go to Role Assignments, that's where we can see all of the role assignments. What we're going to do is filter out the roles. I'll deselect Select All, and I'm going to turn on the check mark only for custom VM role. There it is. Aha. So we're going to click in the box to select it, and then we're going to click Remove to remove that role assignment, and then choose Yes. So now let's go back to Cloud Shell screen. Let's use the up arrow key to get to the point where we were trying to remove that role assignment. So we were doing that, as you recall, with get-az role definition. We refer to it by name, and we pipe it to remove-az role definition. Let's go ahead and run it. It asks for confirmation. We're going to choose yes. And this time, it liked it. So the role is no longer available. Microsoft Azure policies provide administrators with the ability to control cloud resource access. Now, for example, that would mean perhaps limiting which geographical regions that certain types of virtual machine sizes can be deployed in. You can't do that with role-based access control. Essentially, what you could do with RBAC is determine who can manage virtual machines, but you wouldn't be able to get much more detailed than that. So just like with RBAC rules, we can use built-in Azure policies, or we can build our own custom policies. So policies then are more granular than RBAC. So with policies, for instance, we could prevent administrators from deploying too many virtual machines and leaving them running and therefore racking up our monthly bill. Again, with RBAC, you can't do that. You can determine if people can manage VMs, but that's about it. So the other thing that we should bear in mind is that policies can determine which types of cloud resources can be created in Azure, the geographical locations or regions where they can be deployed. We can even have a policy that adds a default tag value when a resource is deployed if it's not been supplied by the provisioner. Now, policies can also accept parameter values so that you can reuse policies instead of hard coding all of the details in it, such as virtual machines can only be deployed in the Canada East region. Well, you might want to make Canada East a variable so it could accept that input as a parameter. So you have parameter values that can be placed into a policy, and then the policy gets assigned to an Azure subscription, or to a specific resource group, or to what's called a management group. Now, you're going to be interested in management groups if you need to organize multiple Azure subscriptions. If you only have one subscription, it's of no benefit to you. Exclusions can also be made. For example, maybe you have a policy where you want to check to see if virtual machines have disk encryption enabled throughout the entire subscription, except for a development and testing resource group, which might not ever have virtual machine disks encrypted. So you can make exclusions, as in that example. Policies have effects. What do you want the policy to do? It can simply audit. It can audit if something doesn't exist. It can deploy if something doesn't exist, so deploy a resource if it's not there. It can also deny access to a configuration or to deploying something. Now, you might wonder, well, wait a minute. Let's say we don't want to allow deployment into the Western US region. But prior to us configuring that policy, there were VMs already deployed in the Western US region. Well, it's not going to go and delete them once this policy comes into effect. Instead, it's going to mark them as non-compliant. And you can see that when you look at the compliance view. Then there's the notion of Azure policy initiatives. What an initiative is essentially a collection of related policies organized into a group, and that group is called an initiative. So the policy groups or initiatives then get assigned the same way you would normally assign a policy. So as an example, let's say that we have a specific initiative that we're going to call Harden Regional Azure Resources. And it might consist of a number of related policies, such as one to ensure that VM disk encryption is enabled, and also another policy that ensures endpoint protection is enabled. You can manage your Azure policy environment using the portal, using CLI commands, or PowerShell commandlets. In this demo, I'm going to use the portal to work with policy assignments. So in the top center search bar, I'm going to search for policy, and then I'll choose policy from the list of services. I'm going to click on the assignments item in the navigation bar, where I'll see any existing policy assignments and how they were applied, meaning to a scope, whether it's the entire subscription or whether the policy was applied to a resource group within the subscription. So I can click either the Assign Initiative button at the top or Assign Policy. The difference is that an initiative is a named grouping of similar or related policies. That's not what I'm going to do here, so I'm just going to click Assign Policy. Now here you're going to get a list of policies that are available once you start clicking on the policy definition context box over on the right. You can even filter out by types. You can choose custom or just built in. You can also search for something. I'm going to search for the word encrypt. And now we can see that we've got policy definitions. There are 13 of them that contain the word encrypt. One of those is disk encryption should be applied on virtual machines. Now, let's say for regulatory compliance, we need protection of data at rest for virtual machine disks. So we need to do this. I'm going to click that policy and choose select. Now, the default back at the top is that it wants to apply this policy at the resource group scope, which is fine. That's what I want. But I could also click the button to the right of that and choose a management group or, of course, a resource group. But I'm going to leave it as it is at the subscription level. We could also put in exclusions. Perhaps there is a resource group you want to exclude from this. I'm not going to do that. I'm just going to scroll all the way down, make sure that the policy enforcement is enabled, which it is by default, and I'm going to click Review and Create, and then Create. Just remember that when you assign a policy, depending on the number of objects in your subscription, it might take a little while until you get results. Normally, you can expect policy evaluation to take place approximately every 15 or 20 minutes. So let's go to the compliance view. I'll click on that in the navigation bar. And here we can see that we've got our specific policy, disk encryption should be applied to virtual machines, that was applied to the pay-as-you-go subscription, but it's flagging this as being non-compliant. We have 0% compliance. So we have 6 non-compliant items. Well, we can find out what they are by clicking to open up that compliance report. And the idea is that we need to know where to spend our energy. What should we do? Well, we might want to enable encryption, but for which VMs? No problem. If we scroll down, we can see the VMs that were found here to not have disk encryption enabled. In this demonstration, I'm going to use PowerShell to create an Azure policy assignment. To get started, I'm going to click on the Cloud Shell icon up at the top. The first thing I'll do is create a variable called $RG for resource group, which will store the result of running get-az resource group, and the name I'm supplying is a resource group called AZ-500. Let's press enter, let's type $RG, and of course, There you go. It's pointing to that resource group. Now, the reason we want to do that is because we're going to go ahead and add a policy assignment. And I want to do it at the resource group level, for example, as opposed to the subscription level. So I'm going to create a definition variable, $definition, that's going to store the result of running get-az policy definition. Now I'm piping that commandlet, so using the vertical pipe, to the where-object commandlet, my filtering commandlet. And I've got my filtering expression here within opening and closing curly braces. So I'm using the built-in placeholder variable in PowerShell, $_. Now bear in mind, get-az policy definition is going to return a lot of policy definitions. We need to cycle through each one of them, and we can use this placeholder variable to do that. It's like a built-in loop, so to speak. And I'm calling upon the .properties, property, and then .displayName. So the display name of the policy definition, and I'm checking to see if it equals audit VMs that do not use managed disks. So I'm going to go ahead and press enter. Basically, we need a variable that points to a policy. Next, I've run the new -az policy assignment commandlet, and I've given it the name of the assignment, which I'm just calling here VMs-managed disks, -display name, check for VM managed disks. The scope, so -scope, I'm calling upon my resource group variable, $RG, specifically the .resource ID property. And then -policy definition, well, I'm just passing it our definition variable that we defined up above that points to that policy. And we can see here that we now have a policy assignment called VMs managed disks, and we can see it applies here to the AZ-500 resource group. Of course, we could also check that out in the portal, so why don't we do that? Let's minimize Cloud Shell. Let's refresh our list of assignments here, and I can see it right away. Check for VM managed disks, and we can see that that's been applied at the AZ-500 resource group level. You can build your own custom Azure policies that you can apply to a subscription or a resource group. In this example, we're going to do that using the portal. So here in the portal, I'll first start by searching for policy in the top search bar. So I'll just go ahead and click policy. Now I can go to the definitions view here in the navigation bar to see existing policy definition. However, I want to create a new one. So I'm going to click the add policy definition button up at the top. For the definition location, I'm going to click the button over on the right, and I'm going to select my pay-as-you-go subscription, and I'll choose select. And I'm going to call this VNet Storage Account Management. Okay, that's the name of it. I'm going to create a new policy down below. Now, I've already pasted in some of my custom information here. So essentially, we've got a policy rule that's checking whether a request is related to Microsoft Network Virtual Networks, network security groups, or anything related to Microsoft.storage. So we can see /*. So anything related to storage. So if a request, if an administrator is trying to manage something that is not any of these, then the effect will be to deny that request. Okay, so let's go ahead, scroll down, and let's save that policy definition. And after a moment, we're going to see that it's listed here. Now, of course, we could just go to the types drop-down list and choose custom, and I can see VNet Storage Account Management. That was what we just created a moment ago. So at this point, we have the ability to assign it. So if I were to go to assignments, then we would be able to assign a policy. Again, I could filter the list for custom policies instead of having to look through everything. That would happen when I go down to the policy definition area. So I'll click there, and this is where I'm going to filter it under the type, drop down list for custom. And there it is, VNet Storage Account Management. So we could apply this to a scope and have it take effect in Azure. Microsoft Azure supports the notion of resource locking. A resource is an item in the Azure cloud, such as a virtual machine. It could even be a resource group, a subscription, a storage account, Basically anything you can deploy in Azure. By locking that resource, you can prevent modifications to it or even its deletion. So to get started here in the portal, I'm going to click on the resource groups view on the left. I'm doing that because I want to set a resource lock on a resource group I have called AZ-500. Now, when you lock a resource group, every item that was deployed in that resource group, which you can see in the overview blade for it, over here on the right, all of these items will also be locked. So they inherit the lock setting for the resource group. And if that's what your intention is, then locking at the resource group level makes sense. That is my intention. So in the navigation bar, I'm just going to scroll down and choose locks. Any existing locks will show up here. We can see clearly there are none. So I'm going to go ahead and click add. And for the lock name, I'm going to call it lock1. And then I can specify the lock type. Do we want to prevent modifications? So do we want to set the lock as read-only or delete? I'm going to set it as read-only. But you could prevent deletion if you wanted to. I'm going to go ahead and click OK. And after a moment, we can see that a lock has been enabled for the AZ-500 resource group. Let's check one of the resources deployed into that resource group. So let's go into the overview blade here. It doesn't really matter which resource we pick on. How about the first one in the list, which is a container registry. So I'm opening up the navigation bar for this deployed item. And if I scroll down and take a look at the locks, then we should see that we have an inherited lock. So lock 1 is inherited from the AZ-500 scope, and the lock type is set to read only. Now that means that if I go to make changes here, so for example, if I go to the access keys, and if I go to regenerate, well, that's going to be a problem. Go ahead and try that. It's not going to work because we've set this object to be read only. And so in our notification bar, it says it failed to regenerate the access key. So of course, we can go into locks where we just viewed what we had. And what we can do is see the scope where it was applied and then go and remove it if we so choose. So back here at the AZ-500 level, if I go to locks, we'll see it's there. I can click edit over on the right. And from here, we can determine if we want to change it from read only to delete. However, I don't want to change it, I want to remove it. So to do that, I'm going to click on the subscription button at the top where I can see resource locks. There's ours for AZ-500. And I can go ahead and delete that. So I can click the trash can to remove it. So I'm just going to click on delete next to it, and it's done. So now let's close out of that. Let's go back into the first resource deployed in that resource group. So that's the container registry. Remember we were trying to regenerate access keys and it said no because it was set to read only. Well, let's see what happens now. So we're going to go to the access keys blade, and we're going to try to make a change here. In this case, it's just going to be to regenerate the key. And I'm going to choose yes, and it regenerated it, and this time it successfully did it because the object's no longer read-only. In this demonstration, I'm going to use the Azure CLI to create an Azure resource lock. Here in the portal, I'm going to click on the Cloud Shell icon. In this example, I'm going to use the AZ lock create command prefix to create a resource lock on a resource group. So I'm going to name this lock with the -- name parameter lock2. -- resource group specifies the resource group. In this case, I want that to be one called AZ-500. Let me just clean up my syntax here. And I'm going to set -- lock type to read only as opposed to preventing deletion. I'm going to go ahead and press enter to create this resource lock. Now, I can also run the AZ lock space list command to return any locks, such as, let's just scroll back up a little bit here. Here it is for AZ-500. Now, we'll also see that, of course, here in the portal. Let's minimize Cloud Shell for a second, and let's just take a look at our resource groups. Let's open up AZ-500, since that's where we applied the lock. And we're going to click on the locks item here in the navigation bar. We should see a lock here named lock2. And in fact, it is set here. And of course, we can see the type is read only. So, in this course, we've examined role-based access control and Azure policies, and how each can be used to control access to Azure resources. We did this by exploring how to use RBAC roles in Azure, how to create a custom RBAC role, how to use the GUI, the CLI, and PowerShell to manage RBAC, and we also talked about how to use policies in Azure. Now we took that a bit further and we talked about how to use the GUI and PowerShell to configure policies. We talked about how you can create a custom policy, and finally, how to use the GUI, the CLI, and PowerShell to lock an Azure resource. In our next course, we'll move on to explore how to improve performance and security by monitoring and analyzing Azure resource usage. An important part of securing your Azure cloud computing environment is having the ability to identify things that are out of the norm. And that's where baselines come in. Baselines can be applied to a network. They can be applied to an individual host, or to a specific application, or all of these items at once. Baselines allow us to determine what's normal. And what's normal is going to vary from one organization to another, whether it's at the network host or app level. So the idea is that after having established a baseline, we can easily spot something that's different, an anomaly, which could potentially indicate a security incident. Baselines come in two flavors. You have security baselines, which could be applied in such a way that we have a specific configuration that we might want applied for Windows virtual machines in Azure. And we can configure desired state configuration, or DSC, to check that that configuration is still in place. Otherwise, we can enable auto remediation. And so that's a security type of baseline. The other type of baseline, of course, is a performance baseline, where we might want to make sure that our application workloads are running in such a way that users have a good experience running applications. Even if users aren't interfacing with anything directly, we might have some kind of an HDinsight cluster to analyze big data. We still want to make sure that's performing optimally. So baseline anomalies could come in the form of a busy CPU. So if you've got CPUs in virtual machines that are much busier than they normally are for extended periods of time, it could be indicative of some kind of cryptocurrency mining, which is computationally expensive, or ransomware, which is also computationally expensive because of all the encryption that it's doing. If you have excessive network traffic beyond what's normal, it could be indicative of a distributed denial of service or a DDoS attack, essentially a flooding attack against a host on a network or an entire network. We also have to consider whether we might see things like device operating system changes. Now we can track that through gathering inventory through an automation account. And so if we've got an operating system that shows up as being different all the time, yet the underlying hardware, such as the MAC address, does not change, that could be indicative of someone booting up an operating system, perhaps to execute an attack on the network. The other thing is to think about what's irregular in terms of timing. So we might have privileges granted to users, for instance, that are okay, they're normal, but it might be strange that we've got system and data access using those permissions at irregular times. All of these things we have to consider when it comes to baselines and then defining what is abnormal. It all falls under the security umbrella. Every Microsoft Azure resource has an activity log, and that activity log records activities related to the interfacing with that item through Azure, so management operations essentially. So as an example here in the portal, I've opened up the navigation bar for an existing virtual machine. What I want to do is click Activity Log to open that blade. Now on the right, we're going to see an activity log listing with the number of filtering options, such as the management group that we want this applied to, the subscription, the time span, the event severity, and so on. So I'm going to change the time span from the last 6 hours, where we see that there are no events to display. I'm going to click on that, and I'm going to choose the last month, then I'll click Apply. Now immediately you're going to notice a change. There's a lot of activity over the last month, and a lot of that activity spreads across many different types of categories. So let's start filtering a couple of items. Up at the top, the event severity is set to all. So if I click on that, I can filter on that by opening the drop-down list. Maybe the only things I'm interested in are not warnings or informational, but instead just critical and error. This way, it allows me to focus my energy on problematic items, not normal operation items. Although, that's not to say that just because we have warning or informational activity log entries, that everything is good. Sometimes that can also be indicative of a security compromise. Anyhow, here we have a couple of failed items, which we can expand by clicking the little triangle. Of course, we can click on it to open it up directly. Here we have some kind of a failure related to the creation or updating of a virtual machine extension. We can see the date and timestamp, who initiated it, which account. So I'm going to go ahead and close that out, and we're going to change the filter again. So currently, we are filtering on only 2 event severities. So I'm going to change that up, and I'm going to select the other 2, warning and informational. The other thing that we can do is filter by a different item, such as the category of operation. Here we can see there are policy actions and health events and the deallocation or stopping of a virtual machine. We can see exactly when it happened. Again, we can see who it was initiated by. But this time, I'm going to click Add Filter at the top, and I'm interested in the event category. From the event category over to the right, I can choose what I'm primarily interested in. For example, I'm interested in policy operations. That would be Azure policy as it relates to this virtual machine. So I'll choose policy. It filters the list, and we have a number of policy actions that occurred very recently. Now, if we click to start opening that up, we can even view the JSON to get even further detail to read about what was occurring at that specific time for policy. So it looks like here we've got some kind of a policy that's checking for disk encryption on the virtual machine. Now from here, we can also even click New Alert Rule so that we get an alert notification when this type of log entry in the activity log shows up. However, I'm going to close that out, but we could do it if we chose to do that. The other thing is at the top here of the activity log, you've also got diagnostic settings where you can specify archiving details. So I can click Add Diagnostic Setting, and I might want to configure archiving to a storage account. Of course, I'd have to choose the storage account, and after I've done that, I can also specify exactly what I'm interested in. Maybe I want to archive policy operations against this virtual machine. So we have a number of options related to that. Let's close out of that. We also have the ability to even download this activity as a CSV or a comma-separated value file. That way we might feed it into some kind of analytics system, or maybe even simply open it up in Microsoft Excel so we can massage the data further. A log analytics workspace is an Azure resource that you absolutely must configure to gain insights about activity and usage of your Azure resources, having a centralized repository of that information. So let's go ahead here in the portal and create a log analytics workspace. We're going to start by clicking Create a Resource in the upper left. And in the search bar that pops up, I'm going to go ahead and search for log. And I'm going to choose Log Analytics, and then I'll go ahead and click Create. I'm going to name this Log Analytics Canada West, and of course I have to tie it to a subscription and a resource group and a location. So here maybe I'll choose Canada Central, and I'll click OK. So all we're doing is creating the Log Analytics Workspace cloud resource. It needs to be configured further so you can determine what the data sources are. Where is all this data coming from that needs to be ingested into the Log Analytics Workspace for analysis? Well, we're going to answer that question after it is successfully deployed. We'll take a peek. All right, and after a moment, in the bell notification icon area in the upper right of the portal, if you open it up, you'll see that the deployment will have succeeded. So let's go to the All Resources view. We're just going to click OK. And what we're going to do is filter the list for Log Analytic Workspace objects. So to do that, I'm going to click on Type equals All, and I'm going to uncheck Select All, of course. And this is an alphabetical list of resources that we've got deployed. So in the L's, sure enough, there's Log Analytics Workspace. We can see that we actually have 8 of them. So I'm going to go ahead and click outside, and there we go. So if we scroll through the list, we'll see that we have our newly created Log Analytics workspace named Log Analytics Canada West. And if I click on it to open up its properties, to look at its navigation bar, we'll see we have a number of items available here. For example, I can go down and look at the workspace summary. Now, we don't have anything gathered yet, so there's not going to be really too much that's overly interesting here. But there will be once data starts getting ingested. Speaking of which, if we scroll down further, then we'll see under Workspace Data Sources the options that are available. We've got virtual machines. When I click on virtual machines, just because they're in the list here does not mean that they are tied to this Log Analytics workspace. Now, you can see that under the Log Analytics connection column. We see a number of virtual machines tied to other workspaces, and in some cases that aren't even connected at all. It says not connected. You can click on any of these items and disconnect it or connect it to the workspace of your choosing. We also have storage account logs that we can select as data sources. So we could click Add to select those. Azure activity logs as well. So we can see here our subscription that we could use to connect to this Log Analytics workspace. So as you add these items, including things like automation accounts, the relationship here between an automation account and the Log Analytics workspace is that the automation account allows us to do things like automate update management and also gather inventory of items that are out there and even apply security baseline configurations through desired state configuration or DSC. Working with the Log Analytics workspace object in Azure is only important if you've added data sources. It needs to ingest data and analyze it over time to provide valuable insights. So for example, here in the portal, I'm going to open up an existing Log Analytics workspace. When you open that up, in the navigation bar, you need to scroll all the way down to Workspace Data Sources to see the data sources. If I click on Virtual Machines, I'll see a list of virtual machines that are both connected to this workspace, those that are not connected to anything, such as in the case of virtual machine scale sets, and also virtual machines connected to other workspaces. Now, if you click on a virtual machine, you have the ability to disconnect it from other workspaces and connect it to this one. Now, you might organize it such that you have a Log Analytics workspace within one administrative boundary in your Azure environment. For example, if you have a Western region IT team, then you might create a Log Analytics workspace for the Western region and add virtual machines deployed in the Western region as data sources to that Log Analytics workspace. But of course, it's more than just virtual machines that we can add as data sources. We see here we've got storage account logs. When I click that, I can click the Add button, and I can start selecting a storage account. So for example, I'm going to click to do that. You can have one or more storage accounts. So I'm going to go ahead and scroll down and choose one of interest. Then under data type, we can specify what we want from that storage account. Do we want IIS logs for the Microsoft Internet Information Services web service stack? Do we want to get specific events, the Linux syslog entries, Service Fabric events, and so on? So once we've selected the appropriate item, we can then click OK, and we will have added that storage account specific item as yet another data source to be ingested by our workspace. We can also click on Azure Activity Log. From here, we can click on a subscription and we can connect it to this particular workspace. Now, why would we do this? Well, activity logs show us log activity related to the Azure administrative side of the cloud resource, as opposed to, for example, what's actually happening within an application running in a VM. You would just get activity about the VM and its management. So we can add that as a data source as well. You can run your own log queries against the data ingested by a Log Analytics workspace. One way to do that indirectly is by viewing activity logs of another resource. So for example, here in the portal, I'm going to open up a virtual machine by clicking on it, and I'm interested in viewing the activity log for it. So I click activity log in the navigation panel to open that blade. The activity log, of course, shows us information related to the management of this Azure cloud resource. So for example, I'll click the time span filter and choose last month. Let's view data for the last month, and then we'll see what's available down there. However, we also have the option of clicking logs up at the top, as we can see. When I click logs, what it's going to do is show me some detail about Azure activity linked to a workspace. So we can see the workspace is listed here in parentheses. This is the log analytics workspace. So I'm going to go ahead and click on that to connect to it. Now, when I'm in here, what I can see is any activity related to logging as per the workspace. For example, I could see that we've got a lot of activity that succeeded versus failed. And if I actually click on that, we can get more details about those successful log activity items. So what it does is it automatically takes us into a log query within that specific log analytics workspace, and it actually populates it automatically for us, and we can see the results of that query listed down below. However, that's in direct access to running a log query in the log analytics workspace. Of course, we can do it directly. So if I click to open up an existing log analytics workspace object, within it, in the navigation bar, I can scroll down and choose logs. Now from here, I have the ability to browse through some of the collected information that's available here in our workspace. So I could expand, for example, anti-malware and protection status. Protection status is actually a table name, and we can actually see the columns or field definitions within that table, the names of them, also the data type. The little italicized lowercase t means that it is a text item or a text field. Now, the great thing about this is you can add any of these columns to your query simply by double-clicking it. So now we can see the protection status column, for example, has been added here, and I can run that query, which essentially is just asking for that information. And we can see down below the results of the query, date and time stamped. We can even scroll over and see, oh, in this case, it's tied to a virtual machine named My Docker VM. And if I scroll all the way over, oh, I see. No anti-malware tool was detected. So we can run queries, log queries, based on what's been gathered here within our log analytics workspace. But remember, it's a lot more than just checking the anti-malware protection status. It really depends on exactly what type of information was gathered. In other words, the amount of data sources that were added here and the activity generated by each of them. But if we scroll over a little bit, you'll also see that we have the option at the top of running a number of sample queries that are built for us. Now what that does is open a new query window, as you can see at the top, a new tab, and down below we can see, first of all, the history of queries that we have run, but we also, if we scroll over a little bit to the right, can choose computer availability as a category, and we see a number of sample queries here with the ability to run them. A lot of options available here. We can also look at computer performance, so like CPU usage trends over the last day. That could be very valuable. Now, when I select that query, it puts it in here. So you can see that this one is much more complex than just a simple field name. And at this point, I can run the query to see if we get anything. And if there's nothing to show you, it's simply going to say, no results found. You can use the Azure Monitor service here in the portal to have a centralized way to monitor a wide variety of aspects of your Azure environment. To get started here in the portal, in the top center search bar, I'm going to search for Monitor, and then I'll choose the Monitor service. Now that's going to open up the navigation panel for the Monitor service, where, for example, in the Overview blade, we have an introductory type of screen where, for example, we could click Explore Metrics. If we want to explore metrics, let's say, related to a virtual machine. Now, of course, you can do this at the individual virtual machine level, but the idea here is that it's centralized. Our monitoring activities are available centrally here through the Azure Monitor service. So I could click Add Metric, I could select a scope, and I could select a virtual machine and the specific metric I'm interested in, and so on. So I'm going to select here my pay-as-you-go subscription. I can choose a specific resource group, And I can scroll down even within that and then start selecting something that I want to monitor, such as a virtual machine. Then I'll click Apply. Then I can choose the appropriate metric. So maybe, for example, I'm interested in disk read bytes. And after a moment, it will chart that information if there is any information to see. So we can explore a variety of metrics. We can search through logs and set up alerts and actions. A lot of these items are available throughout this navigation panel on the left. So for example, if I click on alerts, here I can configure my alert environment, such as creating an action group. So if I click Manage Actions, I can create an action that might determine if admins are notified via an SMS text message or an email notification. We can add numerous action groups to do just that. Then, of course, we can manage our alert rules if we want notification when certain items happen in our environment, such as CPU utilization and failure for specific items, even within an Azure Kubernetes cluster. So we have a number of options available here in Azure Monitor. We can also, under the Insights section, view information related to application workloads. So if I click Applications, and let's say I'm interested in one particular deployed web app, I could select it from the list. And I can scroll down over in the right-hand panel to view some activity, such as failed requests for the web app, the server response time. But notice that the time span here is it's only showing data for the last hour. So let's say we want to see that for the last 30 days to get a better overall sense of performance or the number of failed requests. So we can see here the server response time, for instance, is measured in milliseconds, ms. And we can see if it's been going up or down, the server response time. We can also see when we had a peak number of server requests. So it looks like here between November 3rd and 10, we had a number of server requests that jumped up, well, close to the 150 mark. So there's a lot to be learned that way. I'm going to go ahead and click the X to close out of that application insight. We can also click on virtual machines under Insights to get more information or visibility about the health and performance of virtual machines. Same with storage accounts and even our network environment in Azure. If I click Networks, we get the same type of options. So we can see here our network health, so availability for things like application gateways, which here with the green bar, there is one and it seems to be healthy. We can also click useful links here and choose Network Watcher. That takes us into a whole other set of network-specific monitoring items, such as clicking Topology. And when we click Topology, we'll have to then select, for example, a resource group and then a virtual network within it. So I'll go ahead and select something from the list. This way, we can get a topology map built, where our VNet is at the top. Underneath that, we've got subnets, and underneath that, we can see the linked interfaces, network interfaces with subnets, and below that, finally, what it's tied to, such as a virtual machine or a network security group, that type of item. We can also, if we click on Packet Capture in the navigation panel, capture network traffic for virtual machines. And once we've done that, we can actually save that packet capture and then analyze it using any tool that we really want, such as Wireshark. You can use the Azure Monitor service in the portal to enable packet capturing for Azure virtual machines. Packet capturing can be interesting for analysis because it could be used, number one, to establish a baseline of normal network activity related to a VM, or it could be used to detect anomalies on the network. We might capture network traffic that looks suspicious. So to get started here in the portal, I'm going to click in the top center search bar and type in Monitor, and I'm going to search for Monitor. That way we can launch the Azure Monitor service. I'm interested down under the Insights section in the Networks option. So I'm going to click Networks. And then over on the right, I'm going to click Useful Links. And underneath Useful Links, I'm going to choose Network Watcher. That's where we can do, among other things, packet capturing. So I'm going to click Packet Capture. And any existing packet capture definitions will be shown in the list. I can add new ones, which I'm going to do here by clicking Add. So I'm going to have to fill in a few details before we can get this started, such as a resource group. Now I'm selecting the resource group based on the virtual machine that I'm interested in capturing network traffic for. So let's say it's for a virtual machine called my Docker VM. I need a packet capture name. So I'm going to call it Docker packet capture. Now it's going to be stored as a .cap file, which you might open up and analyze using tools that support that file format. So that would include tools like the free Wireshark Network Protocol Analyzer tool. And we can store this output, so the cap file, the packet capture file, in a storage account, as well as in a local file path. However, here I'm just going to leave it in a storage account. So I have to select the appropriate storage account where I want this stored. And I determine how many bytes per packet I'm interested in capturing. If I put in the default value of 0, as it says, it will capture everything about the packet, the entire packet, all of the headers, and the payload. I can specify the maximum number of bytes per session and also the time limit. And I can also add a filter. This is a packet capturing filter. So down below, we can specify the protocol we're most interested in or the local and remote IP address and port information. So once I've filled in the appropriate values for these items, I can click OK. And after a moment, if we go to our notification area in the upper right, we can see it successfully added the packet capture. Now just make sure that the virtual machine that you're applying it to is running at the time, otherwise your deployment here will fail. So we can see here, we've got the entire packet being captured according to our configuration. And we can see now that the packet capture is running. So if we wanted to, we could go into the storage account and download the packet capture file and analyze it further using other tools. An Azure Action Group is configured through the Azure Monitor service, and it defines how notifications should take place in the event that a specific alert is raised. So let's get started here in the portal in the top center. I'm going to search for Monitor. I'll click on the Monitor service, and I'm interested in configuring the Alert Action Group. So I'm going to click Alerts in the navigation panel. Now over on the right, I want to click on the Manage Actions button up at the top. You might have existing actions that are placed here by a configuration in Azure, in addition to the ones that you manually add. And I'm going to manually add one. I'm going to click Add Action Group up at the top. What I want to do is I want to make sure that administrators receive an email notification when certain alerts are raised. Now, alerts are a separate configuration from the action group. So this action group will be called Notify Admins via Email. And I'm going to use that same text as the short name, which is required here, as indicated by the red asterisk symbol. So what I then want to do is specify the resource group where this will be deployed, and then actions. Now, before I put in an action name, let's look at the action type drop-down list. So we can run an automation runbook that could be triggered, and you'll see how that fits into things when you configure alerts. We can trigger an Azure function. We could send an email message or an SMS text message or voicemail. We could run a logic app, and so on. So in this case, it's going to be email, SMS, and push voice. So I'm going to call this action a specific name. So I want to do an email here. So I'm going to make sure email is turned on, and I'll specify admins@fakeco.com, assuming that's a valid email address. Then I'm just going to scroll down. And I could turn on a couple of other notification options, but I only want that single item. And I'll click OK. Now we have a problem, first of all, up at the top. It doesn't like this name, and if we hover over it, it says it's too long. Oh, okay. I'm going to call it admin email, and when I click outside of it, it accepts that name. But we're not quite finished yet, because we also have to put in an action name. So I'm going to call this action send email. So we could add multiple actions here that would fall under a single action group. Or you might want to split it out into multiple action groups if they're going to be used differently. For example, if you've got email and SMS text messaging added to the same action group, you are limited in that when you select that action group, people are getting an email and other people are getting text messages. If you want to break it up, maybe for different admin teams, then you should have separate action groups. Anyway, I'm going to go ahead and click OK. And after a moment, we'll see our newly created action group shows up in the list. Notify admins via email. In this demo, I'm going to configure an alert notification, and I'm going to do this through the centralized Azure Monitor service. Now I can search for Monitor in the top search bar. If I've accessed it recently, it'll show up right down here under Azure Services. So I'm going to click on Monitor to open up its navigation panel, and then I'm going to click Alerts. Now the first thing I want to do is check out whether or not there are any action groups. So I'm going to click the Manage Actions button. Action groups determine the target for notifications. I've got one here called Notify Admins via Email. Okay, perfect. That's great. We've got that in place. So I'm going to close that out, and I'm going to build a new alert rule. So I'll click New Alert Rule. I want to notify admins when a specific virtual machine's CPU is abnormally busy. So for the resource, I'll click Select. I need to drill down and select a particular virtual machine in question. So here I'm looking at my subscription. We can filter by subscription, by the resource type, and also by the location. So I'm going to type in VIR and filter by virtual machines. So I'm going to select virtual machines. And from here, for example, I'm going to put a check mark by the appropriate virtual machine I'm interested in monitoring. And then I'll click Done. So I've selected the resource, but I haven't specified a condition for that virtual machine. So under Condition, I'll click Add. I'm interested in percentage CPU, so I'm going to click to select that. And I can see a sampling of the CPU utilization. So we can see it hasn't been overly busy. It's been hovering, well, at the most around 7.5% thereabouts. So having said that, I've now got that added, but down below, I've got to actually add my threshold logic. So I'm going to say if the average CPU utilization is greater than 80%, that's definitely abnormal for this virtual machine. I want to know about it. Okay, so I'm going to click Done. That's the condition. Now down below, what do you want to do about it? Well, we can create an action group, but we already know that we have one that's configured to email administrators. So I'm just going to go ahead and click Select Action Group. And then we're going to choose it here. There it is, Notify Admins via email. I'll click Select. We need a name for this alert rule. Busy CPU. Docker VM, and down below, I'm just going to go down and make sure it's enabled, which it is. So I'm just going to click outside of the name. It checks it, it's good. Now I can click Create Alert Rule. And after a moment in our notification bar, it successfully created the alert rule, which is an important part of monitoring the security of your environment, even if it's related to performance, because that could be indicative of some kind of a network attack or some kind of a security compromise. So I can go back at any point in time to manage alert rules if I want to edit that rule definition. There it is, busy Docker, CPU Docker VM, or I could delete it. And of course, if I close out of here, currently we don't have any alerts, which is good in this context because it means that our Docker virtual machine hasn't gone up beyond 80%. So, in this course, we've examined how to improve performance and security through the monitoring and analyzing of Azure resource usage. We did this by exploring how to identify performance and security baselines, how to view and filter Azure Cloud Resource Activity Logs, how to create a log analytics workspace and manage log analytics workspace data sources, and how to run log queries. We also took a look at how to use the Azure Monitor tool and how to capture Azure VM network traffic, and finally, how to create an action group and configure alert notifications. In our next course, we'll move on to explore the Azure Security Center and how its recommendations can improve the security of Azure resources. The Azure Security Center is an absolute centralized wealth of security-related information that is specific to your Azure computing environment. So let's take a look at it. Here in the portal, in the left-hand navigator bar, I'm scrolling all the way down and choosing Security Center. Now, the first thing I'll notice in the overview of the Security Center is I have a general, quick dashboard way of getting a sense of my overall security posture in terms of the use of my Azure resources. So we can see, for example, as we scroll down, our resource security hygiene It's all color coordinated along with the legend. So high severity issues are red, medium severity are orange, and low severity items are blue. Now we can view the recommendations based on what the Security Center has gathered and learned about our Azure configurations. So if I scroll down in the navigation bar under Resource Security Hygiene, I'll see the recommendations option. So I'm going to click on that to open that blade. Now the first thing I notice at the top is I can download a comma-separated value file or CSV report listing all of these recommendations. That could be useful in case we have to feed that into some kind of a task management IT piece of software for delegation. However, we can view everything here. If I scroll down, for example, the first recommendation is that just-in-time network access control should be applied on virtual machines. Essentially what that means is enabling time-limited access to a VM from a specific IP range and opening up a port for the VM, again, for a limited time range. If I actually click to open up that recommendation, the cool thing is that it actually shows me the affected, in this case, virtual machines. And I could either select individual VMs by clicking the boxes, and I can then click Enable JIT, in this case, just-in-time access on the two VMs. So you've got remediation capabilities built into this directly in where you read about the recommendation. Very convenient. I'm just going to close out of that. Then the next one I have, a monitoring agent should be installed on a virtual machine scale set. Okay. So I can click on that to open up and read about the details, including the item in question. So as I go further and further down, here I've got a scale set called, let's say, Web App 1 scale set. And again, notice right away, I've got a remediate button. So again, beyond just having a recommendation, there is a quick and easy way to remediate these security issues directly in this interface, if you choose to do it that way. You don't have to. Next, vulnerability assessment solution should be installed on my virtual machines. If I click, it's talking specifically about two VMs here. So I could select them and I could install that monitoring agent on those VMs. Again, the ability to remediate these issues directly in with the recommendations. In the portal, you can view Azure Security Center threat alerts. So I've already navigated to Security Center by clicking on it in the left-hand nav, and I'm going to scroll down in the Security Center navigator. I'm going to scroll all the way down under Threat Protection where I'll see Security Alerts. So when I click Security Alerts, as you might guess, it allows us to focus on what really happened in terms of security incidents, at least potential security incidents, to bring it to our awareness. So for example, we've got a failed SSH brute force attack. That doesn't sound good. So if I click on it to open it up, we'll get some details about that item. It's for a VM named MyDockerVM. The number of occurrences has a count value of only 1. Well, that's good. And I can see the date and time where there is a potential failed SSH brute force attack. Now, over on the far right, I can dismiss this if I decide, well, that's a false positive. That was me forgetting the password as I tried to authenticate through SSH to that VM. However, it could also be the real thing. Now, of course, we can see by looking at the legend in the chart that we've got 3 medium severity issues, and we can see that they fell somewhere between, let's see, the 3rd, which is of November, Sunday, and the 10th of November. And we can see them listed down here, of course. We already looked at the first one, the failed SSH brute force attack. The next one is suspicious authentication. Well, that sounds like something we should examine. And we can see the specific virtual machine here that potentially could have been attacked or compromised or otherwise affected by suspicious authentication activity. And if I click on it to open it up in more detail, we can see here it says none of them succeeded, but it looks like some kind of a dictionary attack where there were numerous authentication attempts against an account, and they failed. And that's why this was triggered. So this is a wealth of information that we can refer to that doesn't show us any recommendations of what we should do. It shows us a record of potential security incidents. And of course, we can download a CSV report that we might want to analyze further in another piece of software. Regulatory compliance is an important aspect of cloud computing. Your organization, depending on the industry it's in and where it conducts business and where its customers are, might be affected by specific laws and regulations. And so we can control how that gets checked against our configuration here in the Azure Security Center, which I've already launched in the portal by clicking Security Center in the left-hand navigator. When you're looking at the overview blade of Security Center, one of the first things you'll see is policy and compliance. You can see the overall score, 371 out of 755. That doesn't sound too good. And I can see regulatory compliance details listed over here. For example, for PCI DSS, the Payment Card Industry Data Security Standard, which applies to organizations that work with credit card holder data. So we've got 3 of 39 past controls, and we can actually click on these. These are live links if we want to start to read the details related to these items, or these violations, we can call them. So again, we have another chart here, and we can see that we've got 59 failed items. That definitely requires our attention. And it's broken down here by different types of security standards or regulations. For example, here's the PCI DSS 3.2.1 security standard. Let's scroll down and see what it says. So these are standard PCI DSS security categories. So we could drill down under these and see what the problem is. So one of the standards here for securing cardholder data in PCI DSS is to install and maintain a firewall configuration to protect cardholder data. We can see here what's lit up is to build firewall and router configs to restrict connections between different types of networks. If we drill down under that, we can see it talks about restricting inbound and outbound traffic. And then finally, we can start to see how it applies to our environment. So it says IP forwarding should be disabled. Let's click on that to find out more about it. IP forwarding should be disabled. The rule severity is critical. Okay, this sounds like a bad thing. So it says an attacker could use this system to perform IP routing functions, such as routing traffic to their own malicious station to examine traffic, maybe on its way out to the internet. So let's click View Affected Machines, because that's where we need to actually perform some work. So here we can click the appropriate workspace. These are log analytic workspaces to view virtual machines that have this issue. So what it does is take us into a log query where it puts the query in there for us and runs it so we can see the result down here. So one of the offenders here with IP routing is our Azure Kubernetes Service, or AKS, agent pool. That's our cluster to run containerized applications. So I'm just going to close out of these screens. So that's the first thing to bear in mind, is we can read about the different types of compliance settings, but we can also configure it. What I mean by that is in the left-hand navigator here for the Security Center, if I click Regulatory Compliance, here I can turn on different types of standards, security standards, that I want checked against my Azure environment. So what I'm going to do is click the Manage Compliance Policies up at the top. Now the cool thing here is I'm going to select my subscription to view the security policy related to this, and if I scroll down, I can see the current industry and regulatory standards that are currently enabled. We can see it says out of the box, but here I can click Add More Standards. So for example, maybe I'm interested in the Canada Federal PBMM standards in terms of measuring that against how my Azure environment is configured. Now, what that specific type of item is about is contracting for work with the federal government of Canada, as we can see here on the Government of Canada website, where it talks about levels of security, so security requirements that need to be met. And we've even got a PDF here that we can view related to that information. So levels of security for sensitive government information and assets, in this case for contractors. So for Canada Federal PBMM, I'm going to go ahead and click the Add button to the far right. Essentially what this is a collection of Azure policies, in other words, a policy initiative that's being applied, in this case, at the subscription level. Although we could change that to a specific resource group if we really wanted to by choosing it from the list. And so this would take a look at the Azure resources within that resource group to check for compliance with these security standards. So I'm going to go ahead and choose that. And as we go further down below here, we can also exclude specific members, such as administrator accounts in Azure. And here, for inclusion, I'll put in a user account by the name of C. Blackwell. And then I'll go down and click Assign. In this demonstration, I'm going to configure just-in-time virtual machine access. So instead of administrators always having the appropriate role permissions to manage VMs in Azure, we can set it so that it's only available after it's been requested, and then also open up firewall ports accordingly to allow that administration for a limited period of time. To get started here in the portal, I've already navigated to the virtual machines view. I'm going to click on an existing virtual machine. When you want to enable just-in-time access, you need to scroll down in the navigation bar and you need to click on Configuration. If, for this virtual machine, just-in-time access has not yet been enabled, then you'll see this button to enable it. So I'm going to go ahead and click Enable Just-in-Time. And it says if you want to edit or disable this after the fact, open it in Azure Security Center. And there's a link to go there. Now here I'm going to see that just-in-time access is enabled for my virtual machine that we were just in. It's called my Docker VM. Now, at any point in time, I can scroll over and click the three dots over on the right. That's the context menu for that listing. And I can remove it from here, which disables just-in-time access. However, to use just-in-time access here from the Security Center, if I need to administer some aspect of that VM, I could turn on the checkmark for the VM and choose Request Access. Now from here, when I request access, it knows it's running Ubuntu Linux, and so it knows that port 22 needs to be on in order for me to remotely manage it over SSH. So I'm going to go ahead and turn that on. I can also specify an IP range that type of access should be allowed from, and then enter a request justification. So I'm going to put here, need to update custom app components for app 1. And then I can click the Open Ports button over on the right. And we can see here that we have one request that was just approved. And all that will do is make sure that access to the VM is allowed from the configured IP address to port 22. Now, if I were to put a check mark by that VM again and click Request Access, notice that the default timing for this is 3 hours, although that's configurable. So that's how long that firewall port will be open for the IP address range to allow SSH access. File integrity monitoring has been around for decades in a variety of different operating systems. Essentially, it allows us to take a hash of a file, and then that is a unique value based on the file contents. In the future, when we generate the hash again, if it's exactly the same, then it means that no changes were made to that file. But if the hash that's currently been generated is different, we know that updates have been made to that file. And so this is great because in Azure, we can set that up centrally through the Azure Security Center. So in the portal here, I've already opened up the Security Center by clicking Security Center on the far left. And if I scroll down in the navigation bar, under the Advanced Cloud Defense section, I'll see a File Integrity Monitoring option. So I want to click on that. I'm then presented with a list of log analytics workspaces. So I'm going to choose one of my workspaces. And then it takes me to enable file integrity monitoring for it. So I'm going to go ahead and enable file integrity monitoring. Notice it knows up above that I've got one Windows computer and one Linux computer, those are VMs, that are added as data sources to the selected log analytics workspace. So that's perfect. I'm going to go ahead and choose enable file integrity monitoring. And after a moment, it takes us to the file integrity monitoring screen where it says it's initializing it and it can take up to 1 hour before any information shows here related to files in those virtual machines, files and registry settings. And before too long, it'll be ready to go. So we can see that there are 2 total computers. They're listed here. And we don't yet have any changes for files or registry entries and when the last change occurred. However, I can click Settings to see what it will be looking at for changes. So that's in the workspace configuration. So here in the Windows registry, here's where it's going to be looking to see if there are any changes made. But you can also click Add. The same is true for Windows files. Here's the default files that will be checked. But again, you can click Add. Same thing is true for Linux files that will be monitored, as well as file content change tracking. We can also take a look at Windows services to take a look at any changes to them as well. One of the reasons this is important is because if there's a change made that's unauthorized, it could be an indication of a security compromise. So, in this course, we've examined the Azure Security Center, including how to use it to improve the security of Azure resources. We did this by exploring how to navigate the Azure Security Center, how to view Security Center security alerts, how to manage both Security Center policies and compliance, how to configure just-in-time virtual machine access, and finally, how to enable file integrity monitoring. In our next course, we'll move on to explore the secure implementation and management of Azure resources, including encryption, data masking, as well as working with Azure SQL Firewall. In this exercise, there is a need to limit access to Azure storage accounts. The way that we're going to solve that is by limiting access from specific virtual networks, or VNets, and also to configure role-based access control to limit administrative access to a storage account. Here in the portal, I've already opened up a storage account that I want to control access to from specific VNets. So I'm going to scroll down in the navigation bar until I come across Firewalls and Virtual Networks, where we'll see that the default configuration is to allow access to this storage account from all networks. We're going to limit that scope. So I'm going to click Selected Networks. And down below, I have to either add an existing virtual network or create a new one. I don't want to add a new one, I already have some. So I'm going to choose Add Existing Virtual Network. And from the Virtual Networks drop-down list, I'll choose one of my virtual networks, after which I will then choose a subnet or subnets. I could do a multiple selection within that VNet that I want to allow access to this storage account. After I've done that, I'll click Add, and we can see it's listed down below. Access from subnet 1, which exists in VNet 1, will be allowed. So I'm just going to click Save to update that. Now, I also want to limit administrative access to this specific storage account. So for that, in the navigation bar, I'm going to click Access Control IAM, and I'm going to make an RBAC role assignment. So I'm going to click Add Role Assignment. So I've filtered the list of roles by typing in STOR. I'm interested in allowing contributions to storage blobs, so uploading of blobs. So I'm going to choose the storage blob data contributor role, and I'm going to assign that to a particular user. In this case, that user will be Cody Blackwell. It could be a group as well. And I'll just click Save, and it's done. So if I check out the role assignments at this particular resource level, I can filter the list of roles. I'll deselect Select All, and I'm interested in the storage blob data contributor. When I take a look at that, indeed, we can see Cody Blackwell was assigned at this resource level. In this exercise, the business requirement is to use custom keys to encrypt storage account contents. Now, custom keys means keys that are managed by the customer and not by Microsoft Azure. So the solution is going to be to use a key defined in an Azure key vault. So you need a key vault, you create a key in it, and then we can reference that key in the key vault to configure storage account encryption. Here in the portal, I've already navigated to an existing Azure key vault named KV444. And if I take a look at the keys that exist in this vault, there are 3 of them. They're all enabled: key 1, key 2, and key 3. So now if I navigate to a storage account where I want to enable encryption with custom keys, I can scroll down under Settings and I can choose Encryption. From here, I have the option of using my own key, which I'll select. I'll just scroll down a bit, and I can also select the key from a key vault. So under Key Vault, I'll click the Select link, and we know it's KV444. Then under Encryption Key, I'll click the Select link to choose a key from that vault. We'll choose key 1, and at this point, I'll click Save. So from this point forward, this is the key that will be used to encrypt contents in this storage account. Of course, it will retroactively encrypt older data. It says at the top, any existing files will be retroactively encrypted by a background encryption process, the key being that it might take a bit of time. In this exercise, there is a need for the expiration of access to a storage account. This could be because we've got developers in for a few days doing work, and they need specific types of access to an account, after which, when that's finished, we want that access to be automatically revoked. And we could do that by generating a shared access signature. Here in the portal, I'm already looking at the navigation bar for an existing storage account that I want to generate a shared access signature for. And so I'm going to scroll down in the nav bar, and I'm very interested in shared access signature. Click on that. The first thing to determine in our example is the type of access developers will need. Perhaps it's only for blobs, so not Azure file shares, message queues, or tables. And then down below, we can determine the specific permissions. So maybe read and list access. For example, maybe the content stored in this account are used for displaying in a web app being worked on by developers, but it's only for display purposes. So read and list. I can specify the starting date and time, which I'll leave. I'm going to set the ending date to be just the end of the week. The time, I can also specify. I'm not going to specify an IP address. I'm just going to generate the shared access signature and connection string. And down below, depending on the tool that's being used to connect by developers, such as writing code or using even the Azure Storage Explorer tool, whatever the case is, will determine whether they need to be supplied with the connection string, the SAS token, or the Blab service SAS URL. In this exercise, the business requirement states that we need secure storage account keys. Now, what that means is we can regenerate keys periodically to increase security. Keeping the same key for a storage account, for access to it, forever and not changing it is a security risk, because if it gets compromised, then the malicious user with that key can keep on accessing that storage account. So we're going to regenerate one of the 2 available storage account access keys. Now, the reason there are 2 is that you can regenerate one while another key stays active in the interim, because otherwise you might break access to the account for those that might already be using an older storage account access key. When you're looking at the properties of a storage account, one of the things you'll see if you scroll down in the navigation bar under Settings is access keys. There are 2 access keys automatically created for every Azure storage account. However, you can use the regenerate icon, which kind of looks like a recycling icon, next to the key that you want to regenerate. So I'm going to keep key 1 as it is, key 1 in the connection string. But for key 2, I want to regenerate it. So I'm going to regenerate by clicking the icon, and I'll choose yes. We have a message now that says successfully regenerated access key 2. Excellent. So down below, we can use key 2 or the connection string depending on what is being used to make a connection to the storage account. Now, keys are different here than shared access signatures, because if you have an access key, you have access to the entire storage account. With a shared access signature, you have limited potential access to the storage account for a limited period of time. So let's make sure we can use key 2 to successfully connect to the storage account. While developers can connect programmatically, for example, using a connection string for the key, here I'm going to use the free Microsoft Azure Storage Explorer tool which I've already downloaded and installed on premises. I'm going to click the plug icon on the left to make a new type of connection. I'm going to select Use a Storage Account Name and Key, and I'll click Next. So here I've entered in a display name, which happens to be the actual storage account name in Azure, and I've pasted in the account key. So at this point, I'm going to click Next and Connect. So after a moment, we'll see that we've actually got a connection to our storage account. Here it is, store account 64845 through a key. And in here, we can see blob containers, file shares, queues, tables, and so on. In this example, there is a requirement such that we have the ability to associate Azure resources, things like virtual machines, storage accounts, and so on, with specific projects taking place in the organization. Now, that allows us to organize things and filter lists based on the project. It can also facilitate billing aspects of things, so we can see, for example, how much a specific project is incurring in Azure Cloud Computing charges. So in order to do this, we're going to add metadata to Azure resources. In other words, we're going to tag them. Tagging can be done using command line tools as well as the GUI, and you can tag resources when you initially deploy them or after the fact, which is what we're going to do. So I'm going to start by going to my virtual machines view, where I've got a virtual machine that's been deployed for a specific project, and I would like to tag it as being associated with that project. The virtual machine is named My Docker VM. So I'm going to go ahead and click to open up the properties, or the navigation bar, for that virtual machine. And one of the things you'll see here is tags. When you click on tags, you'll see existing tag names and values already assigned to this resource. And of course, you can modify those tags or you can add your own. So currently there are no tags listed here. But from the name drop-down list, I can select existing tags that have already been used within my Azure subscription. Or I could simply type in a name and start something new. However, if I go into the Ps, I can see that we've already got a project tag name. Otherwise, I could just type it in to create it if it didn't already exist. Now, I can also select from existing values that have been assigned in my subscription already to other resources, or I can type in a brand new value. It doesn't make a difference. In this case, I'm just going to choose AZ-500 as the project name. Now notice you can add multiple tags for a single cloud resource. And for each one of the tags, you can also delete them. You can also click the Show Resources with Tag button if I want to see other resources already tagged in the same manner. In other words, for project AZ-500. So it shows me here I've got a VNet that's configured in that same manner. Close that, and I'm going to save this tagging information for this virtual machine. Now, one way that proves useful is if you want to go to the All Resources view and filter by tag. There are other ways, but that's one way. So here in the All Resources view, I'm going to add a filter. And the filter here is going to be based on tags. So there's tags, and then we have an alphabetical list of tag names underneath tags. We are interested, of course, in project. So I'm going to set project equal to AZ-500, and we can see all of the Azure resources that are tagged and now associated with that project. In this exercise, there is a need to mask the display of customer email addresses. Customer email addresses are considered personally identifiable information, PII. And as such, you might want to make sure not just anybody can see customer email addresses, for example, when running a query against a database. So the solution in Azure for this is going to be to configure SQL database dynamic data masking. Here in the portal, I've navigated to an existing SQL database named DB172, where in the navigation bar, I'm going to scroll down all the way under Security to choose Dynamic Data Masking. Here, I'm going to see some of the existing recommendations for columns or fields within the customer table and the ability to add a mask. For example, customer email address. Now, I could also manually do this by clicking Add a Mask up at the top. But since it's right there in front of me, I'm going to click Add a Mask next to customer email address. Now, when I go to add a mask for that, it'll add it up above. Now, I've mistakenly selected an additional item to mask, so I'm just going to go in and delete that. So now we can see the customer email address is now masked. Now, what we can do is actually click on that to open it up. If you ever want to change these settings, you can change the masking field format. So for example, I can choose email, where we can only see the first and last couple of letters of the email, such as .com. Same type of thing is possible with credit card numbers. So I'm going to go ahead and do that and choose Update. And it's done. So if we go back here, we'll see that we've got our sales customer email address now using the email masking function. So I'm just going to go ahead and save that dynamic data mask. Bear in mind, if you are logged in as an administrator running queries, you will see the email address. This doesn't mask it from admin privileged users in the database. In this example, the business requirement states that we must be able to allow on-premises admins access to an Azure SQL database. Now, that could require configuring outbound firewall ACL rules on premises, but that's beyond the scope of what we're going to do. But we can control the opposite end of it. We can add a client IP address or range to the Azure SQL firewall. That's what we're going to do to allow inbound access. So here in the portal, I'm already looking at the properties of an existing Azure SQL database. Now, in the overview blade of the database, you'll have a Set Server Firewall button up at the top. So I'm going to go ahead and click on that. Now, this is for the server that is hosting the database I was just in. Now, from here, you can see your current client IP address. So it's already determined that is your public IP address for the machine you are connected to this interface from. So if I want to, I can click Add Client IP, which adds a rule here to the SQL server. And when I click Save, it will be done. So as long as my public IP address doesn't change, so perhaps I'm behind a NAT router, and I'm coming from that location, it will allow inbound access to the SQL server. Of course, you could add a range of IP addresses as well if you needed to. So, in this course, we've examined a number of ways to securely implement and manage Azure resources. We did this by exploring how to control admin access to storage accounts and how to use custom keys to encrypt cloud data. We looked at how to use a shared access signature to limit storage account access and how to use a storage account key to access the contents of that storage account. We looked at how to organize cloud resources through tagging, how to enable database masking, and how to configure Azure SQL Firewall. In our next course, we'll move on to explore additional techniques for the secure implementation and management of Azure resources, including Azure AD password lockout, site-to-site VPN connectivity, and Azure role-based access control. In this exercise, the business requirement is to enhance Azure AD users' sign-in security. Now, that can be done in a number of ways, but the way that we're going to do it is to enable Azure AD multi-factor authentication for the user in question. Here in the portal, I'm going to start by clicking on Azure Active Directory on the left so that I can go into the user's view, and from there, we can fire off the MFA option. So here in the user's view, I'm going to click the More button on the right and choose Multi-Factor Authentication. So that opened up a new page. We have a list of users, and we can see that some users have multi-factor authentication, even beyond enabled, enforced. It's actually being enforced and used currently. So for user Alan Alford, currently MFA is disabled. So I'm simply going to turn on the check mark and click Enable over on the right, and then I'll click Enable Multi-Factor Auth, and it's done. Why don't we log in as Alan Alford and check it out? So I've logged into portal.azure.com, or rather I'm in the midst of logging on. I've specified the user sign-in name and the password. So I'm going to go ahead and click sign in. And because we've just enabled MFA, it says, well, there's more information required. So I'll click next. So from here, the authentication phone option is selected. So I'm going to specify my country and phone number, where it will send a code by text message to the phone. And I'm going to need that to sign in. And I've entered the 6-digit PIN that was sent to my phone. Now I'm going to click done. And we are now signed in as our MFA-enabled user, A. Alfred. In this exercise, we've got a business requirement that states that we need to protect Azure AD user accounts from brute force password attacks. One way to do that, and what we will do to address it, is to enable Azure AD user password lockout. That way, if we've got an automated bot that's performing a brute force attack against an account, after so many incorrect login attempts, the account will be locked, thus thwarting that brute force attack. To get started here in the portal, I'm going to navigate to Azure Active Directory in the left-hand navigator. And the next thing I want to do is go into Security. So I'm going to scroll down and choose Security. That's going to open up a new set of options in the navigation bar. I now want to go into Authentication Methods and finally, Password Protection. So from here, I'm going to set the account lockout threshold to 3. So after 3 incorrect login attempts, we can specify the lockout duration in seconds for that account to be locked out. So let's say 350 seconds. We can also specify a custom password list that is banned, not allowed to be used for security purposes. So at this point, I'm going to save the Azure Password Protection. And now it is in effect and applies to all users in this Azure AD tenant, which we see listed up here in the upper right. In this scenario, the business requirement is such that we need to allow HTTPS port 443 access from the internet to selected Azure VMs. So those Azure VMs are running some kind of a web application workload. To do this, we're going to configure a network security group with an inbound rule. Here in the portal, I'm going to click Create a Resource in the upper left. And in the search field, I'm going to search for Network Security Group, and I'll choose Network Security Group from the resultant list, and then I'll click Create. I'll deploy this into an existing resource group. I'm going to call this HTTP Web App Rules, and I'll deploy this in a specific region or location, and I'll click Review and Create. Now, once it's created, so validation is passed, I'll click Create. We then have to create the inbound firewall rule. You might also choose to build outbound firewall rules. And then, of course, we need to associate the network security group with either network interfaces used by virtual machines or with a subnet in a VNet that contains virtual machine network interfaces. So the deployment's complete, no problem. Let's click Go to Resource because we need to allow port 443 access from the internet. So for inbound security rules, we can see the default rules. We're going to click Add to add our own custom rule. And this custom rule is going to allow access from any IP address, any port range. The destination will be any IP, although it could be for a specific IP, for a specific backend VM. So I could specify, for example, an IP address of a specific backend VM I want to allow access to. In this case, the port is going to be for 43. TCP will be the transport protocol, and the action is going to be allowed. Now, I want to make sure that this inbound firewall security rule is parsed before any of the others. Well, those default ones start at a very high value for just that reason. So a priority of 100 means this rule gets read before the other ones. And I'm going to call this rule allow inbound HTTPS. Then I'll click Add to add that network security group firewall rule. And after a moment, we can see it's now listed. Allow inbound HTTPS to port 443 as a destination, and the IP address of the target server is listed, and of course, the action is set to allow. Now remember, you need to associate this network security group with either network interfaces, so you can associate it by clicking the Associate button, or you can go to subnets and associate it there. So for example, if I want to associate this with an entire subnet that I know has VM network interfaces, and I want those VMs affected by this rule, then I would simply have to choose the appropriate virtual network and then subnet. Let's say I choose VNet 6, and I choose a subnet within that, in this case subnet 1, and OK. So after I've done this, the association allows the inbound rules in that NSG to apply to that subnet. In this exercise, the business requirement is that we need to link an on-premises corporate network under our control with an Azure VNet. Now we want a direct link over the internet that's secured. And to do this, our solution is going to be to configure a VPN site-to-site connection. Okay, so the first thing you need to do this is you need to have created two resources in Azure. You need to have created a local network gateway, which I've done. It's called On-Prem VPN GW1. It's no different than creating any other type of resource in terms of how it's done. But it does have a public IP address. So you need to specify the public-facing IP address of your on-premises VPN appliance. Whether it's hardware or software-based makes no difference at all. However, that's what this cloud object represents. It represents your on-premises VPN configuration. Now, that's one of the things that you need to have created, which I've done. The other thing you need to have created is a virtual network gateway. That represents the Azure VPN side of the connection. So I've got it created here. It's called Azure VPN GW1. Again, you create it like you would create any other type of Azure resource. But if I open up that item, it will give me the public IP address. So just like you need the public IP of your on-prem VPN appliance exposed, so too is the case with the Azure side of that connection. Now you can go into either the local network gateway, or we're going to go into the virtual network gateway only because we're already in it, to define the actual site-to-site VPN link. To do that, here in the navigation bar, I need to go to Connections. There are no connections, so I simply click Add. Now we're here to add a site-to-site VPN link, so I'm going to call it site-to-site VPN. It's not going to be used to link VNets together or connect an on-premises network to Azure through an express route dedicated circuit. That's not what we're doing. We're going to choose site-to-site IPsec VPN. Now, it already filled in the virtual network gateway because that's what we're currently configuring. But we have to choose the local network gateway side of the link. That's the on-prem link. So I'm going to choose the object that we looked at previously, and I need to specify a pre-shared key, a symmetric key that is configured on both ends of the connection. So I'm going to go ahead and do that, and then I'll click OK. Now, before you know it, it'll be showing up in the list. The status is unknown because it will not be able to make the connection to the public IP of our on-prem VPN appliance because that doesn't exist. So I'm going to go ahead and click to open it up because you can also download the configuration. Because if you think about it, you need to configure some aspects of your on-premises VPN appliance, certainly for the pre-shared symmetric key. So we can choose the vendor. Let's say it's a Cisco VPN appliance. It's an adaptive security appliance, and I can choose the firmware version and then download the configuration file that I can run as a script on my on-premises device to configure it accordingly for this site-to-site VPN link. In this scenario, we have a business requirement that states we need to limit how long network security group ports are open for virtual machine access. So that would apply if you are allowing SSH access to a Linux host or RDP access to a Windows host. The way that we're going to do that is we're going to enable virtual machine just-in-time access. So here in the portal, I'll start by navigating to my virtual machines view, and I'm going to select a virtual machine where I want to enable just-in-time access. So I'll click on it to open up its navigation bar. Now to configure just-in-time access, I'm just going to scroll down and choose Configuration. Now if it's already enabled, you'll see that here. But because it's not currently enabled, instead we have a button that says Enable Just-in-Time. So I'm going to go ahead and click that. And it says, okay, well, to work with that further, so to edit or disable it, open it in the Azure Security Center, and a link is provided. How convenient is that? I'm going to click on the link. Now that's going to switch me over to just-in-time VM access for my virtual machine, which is listed here, WinServe 2016-1. Now at any point in time, I can click over here on the far right and remove it from here. However, I'm going to turn on the check mark for it and click Request Access. Now it knows it's a Windows operating system, and so it automatically knows that I probably am interested in enabling port 3389. I'm going to turn that on. And for my specific IP address that I'm currently at running this web browser to do this in the first place, although I could specify a different IP range. Notice the default time range that port will be open is for 3 hours. I could reduce that, let's say, to 1 hour. And the justification reason, config app 1. The app 1 is running in that virtual machine. I'm going to go ahead and click Open Ports. And after a moment, we will have a successful request that was approved to allow a time-limited access to port 3389. In this exercise, there is a need to allow IT auditors to view all Azure objects and their configurations. Now, the way that we're going to solve this in Azure is to first create an auditing group within Azure AD, and then we're going to grant that group the reader built-in RBAC role at the subscription level. Now, we're doing that at the subscription level because it will be inherited by all resource groups in the subscription, and by extension, all resources deployed into those resource groups. So it's going to be a perfect solution. Let's get to it. Okay, here in the portal, I'm going to start by clicking Azure Active Directory over on the left. Then I'm going to go to the Groups view. Next, I'll click the Add New Group button, and I'm going to give this group a name of IT_auditors. It's a security group, and from here I can add members. Now, these members, of course, are users that exist already in Azure Active Directory. So we can scroll through, we can select them, we can filter the list. So in this case, let's say I'll choose 1 or 2 users. I'll click Select, and I'll click Create. So I've created an Azure AD group, is really all I've done at this point. Now let's use it for role-based access control. So at the top center here in the portal, I'm going to search for subscriptions. And in my list of subscriptions, I'll click on the one where I want to set that as the scope for my role assignment. And I'm going to click Access Control IAM. I want to add a role assignment, so that means I'm going to click the Add button on the right, and then I'll choose Add Role Assignment. Now, for the role that I want to assign, I'm just going to filter it out by typing in Read, and then I'll select the Reader built-in role to allow read-only access. And I want to allow that to the IT Auditors group, so I'll filter the list and choose IT Auditors. I'll save that. And at this point, it's done. We have assigned it at the subscription level. Just for kicks, why don't we go to a specific virtual machine in this subscription and check the access control IAM blade. So maybe I'll choose my Docker VM, and I'm going to click Access Control IAM, because at this point I just want to double check my work and verify that the role assignment was inherited down to all of these resources. So for that, of course, I'm going to have to click Role Assignments. And we're then going to filter out the list. We don't want to look at everything. What's the point of doing that? Let's look at what we need to. Reader. And if we take a look, we can see indeed IT Auditors, the group, has Reader. And it was done at the subscription level, which means it's inherited all the way down to this specific virtual machine within that subscription. In this exercise, the business requirement states that we need a way to easily identify weaknesses in our Azure environment. Now, the last thing we want to do is to have to manually comb through every single one of our Azure resources just to check to see that it's configured in a secure manner. There's got to be an automated way to deal with that, and there is. Our solution is going to be to view Azure Security Center recommendations. Here in the Azure portal, I can get to the Azure Security Center in the left-hand navigation bar by scrolling down and choosing Security Center. Now, the first thing that I might want to do is view actual recommendations. So down here, I'm going to click on Recommendations. Now, by doing this, I get some colorful graphs, and I can see immediately I've got some high severity issues that really need to be dealt with. There are 18 of them to be specific. And it's even broken it down by the compute and apps category versus networking versus data storage and identity and access management. I'm a little concerned with the data storage only because it seems to have the highest number of issues along with networking resources. So let's start by clicking on networking resources and see what's going on. Okay, so I've got some risky resources here. Let's take a look and scroll down. It says just-in-time network access control should be applied on all virtual machines. Fair enough. Now, I could click on that specific recommendation to find out where I should focus my energy to take action. Here it is. So I could select the appropriate virtual machines where I want to do that, perhaps all of them, and I can remediate this immediately. I can enable just-in-time access, or JIT, on the selected VMs. Fantastic and convenient and very valuable. We also see here DDoS protection standard should be enabled. That's true. That's done at the virtual network level. And so we could click on that to find out more details about it. So I can just scroll all the way down, and I can see, for example, VNet1 is the affected resource where I may want to enable that type of protection. Now, that's just taking care of a few of the network recommendations that we mentioned. But the other issue that was of concern was this high number of data and storage resources. So there are 36 of them. Let's click on it. Let's focus. Let's zoom in and solve those issues. Let's harden our environment. So it says here, advanced data security should be enabled on your SQL servers. Okay, well, let's take a look at the offending servers where that is not in place. So we can scroll down in the list, and we can see, indeed, these are the servers that are in question. I can put a check mark on them and remediate that issue by clicking the Remediate button. If we go back, we also see that there is a vulnerability assessment that should be enabled on SQL servers. Okay, well, once again, I can click on it, see the offending servers where Azure recommends that be done. I can put a check mark next to each server and then click Remediate. So this way, we have a centralized method by going into the Azure Security Center whereby we can identify weaknesses in our environment so we can focus our energy carefully to harden our environment. So, in this course, we've examined a number of additional ways to securely implement and manage Azure resources. We did this by exploring how to enable Azure AD user multi-factor authentication and how to configure password lockout. We looked at how to create a network security group, how to control access to VNets, how to configure site-to-site VPN connectivity, how to limit resource access through Azure role-based access control, and finally, how to view Azure Security Center recommendations.